Hello and welcome to CitusCon. I am absolutely thrilled that you're all with us here. I know some of you will watch this on replay, but some of you are watching it live. This is called CitusCon, an event for Postgres. My name is Claire Giordano. I head up the Citus and Postgres community initiatives team at Microsoft, and I will be your host for today's live stream. And so before we just talk about and focus on today's live stream, I wanted to let you know there are 38 talks across all of CitusCon. The whole event is virtual. We had live streams earlier today in the Americas time zone and also in APAC. And here we are for the third one. And then there's 20 more on-demand talks. And there's a URL showing on the screen right now that you can look at. I think it's aka.ms/CitusCon-schedule, where you can get to all the information about the talks that are already live online on YouTube, as well as the live streams. And there are, across these 38 talks, 42 speakers. So I wanted to give a big shout out to all the people who have put a lot of time and energy into sharing their expertise with us. And these are people, I think about 40% of the speakers are from Microsoft, but the vast majority of people are from the Postgres community of users and developers around the globe. So really big thank you for joining us and being part of this event. We're committed to accessibility. The Learn TV platform is actually focused on accessibility. So there are captions that are available for you live if you're streaming it on Learn TV. We're also streaming to other platforms as well. So you could be watching from a bunch of different places. But if you're on Learn TV, go ahead and turn on those live captions. And there will be captions on all the on-demand talks as they're published after the event. throughout the event, we also have a code of conduct. Many events do these days. We've all grown to expect it and appreciate it, but I wanted to let you know that while you're here today, involved in Q&A, interacting with other attendees, we'd like you to be friendly, welcoming, respectful, inclusive, and that's certainly what we're going to be doing, trying to be open and curious and learn from each other. There's a URL showing on the screen as well. So if you have any questions or concerns or need to reach out to somebody about anything code of conduct related, you can just go to aka.ms/cituscon-conduct and get to more information. And if you're live tweeting, I'm the host today. So the previous live streams, I tweeted about each and every live stream speaker, but I cannot do that right now. So if any of you are watching and you do the Twitter thing, it's #CitusCon on Twitter. And so please use it if you're tweeting about it. And if you have questions and you are streaming on Learn TV, you can just sign in on the right and ask questions there. We've also set up a Discord server because we've got like 3 different live streams and these intermissions. And so we wanted you to have a place where you could reach the speakers anytime this week and ask questions. So the speakers are going to be popping in and out, but there's this CitusCon channel on the Microsoft open source Discord server. And the URL is also showing over there. Is it over there? Am I pointing the right way? aka.ms/open-source-discord. Now, there's also going to be a recap at the end, or a wrap up, I guess is what it's called. So an extra 25-30 minutes after the last talk, where Marco Slot and I, he's the head of the Citus database engine team, are going to be chit-chatting about everything that's happened so far. And we'll also show some highlight reels to you about some of the other talks. So super short, super easy to digest, and hopefully we'll give you some good teasers of the other information that's out there. There's a survey too. So if you have feedback, please fill out the survey. You don't have to do it just once. Like, you can fill it out today based on the talks that you're seeing now, and then come back tomorrow or later this week based on other talks that you've watched. The survey will close next Tuesday, the 19th of April, at the end of the day anywhere on Earth. So, 11:59 p.m. anywhere on Earth. URL is on the screen for that as well, and we'll be popping it up. So to recap, CitusCon on Twitter, hashtag aka.ms/CitusCon is the URL for the CitusCon website, where you can get to everything: the on-demand talks, the replays, the live streams, everything. There's the link for the open source Discord. And just remember that after all 6 talks today, we're going to stay online and just chat about the show. Feel free to stay, and feel free to drop questions in the Discord for us. And with that, I think it's time for me to introduce our keynote speaker for this live stream. I could not be more happy to welcome Magnus Hagander. I hope I pronounced his name right. I always ask him if I did it right. Magnus is a member of the Postgres core team. He's based in Europe, but his presence is global. And he's also, I think are you president of the Postgres Europe board? Is that correct?
That is correct.
Okay. And I first met you at PGConf.eu because you're generally very involved in the organization of that conference, which is the largest Postgres conference in Europe, held every year until the pandemic, right?
Correct. And if all things go according to plan, we will be back again this year after summer, back in October. So, cross our fingers to see that actually happens, but that is the plan, back in person.
I can't wait. I can't wait to see you all again in person. So you're here to give a keynote about how Postgres is more relevant than ever. And I can't wait to see what you have to say. So with that, we'll pass the baton to you. You're on.
Thank you very much. So yeah, today's topic, Postgres, more relevant than ever. What does that mean? And how did I come to that conclusion? Well, as Claire said, my name is Magnus Hagander. I work for a company called Red Pill Linpro, based not just in Europe, but in Stockholm, in Sweden, where we do all sorts of open source services kind of business, where Postgres is one of our main tracks, where we do support, we do training, we do pure consulting and things like that. So this talk is partially drawing on my experience as a Postgres consultant simply throughout. Within the Postgres group, as Claire said, I'm a member of the core team. I'm one of the developers, though I don't necessarily do as much as I'd like all the time. I'm part of far too many teams to list, like working on infrastructure and things like that. And finally, I am on Postgres Europe, which deals with advocacy things focused around Europe. The way Postgres works is we have different groups around the world. So there is a corresponding Postgres US, for example, for the Americas, things like that. So also drawing on what I hear in my role in the community and see how do we come to this conclusion. So Postgres, we all know it, right? Hopefully everybody who's listening in on this stream has run into Postgres at some point or other. Postgres is old. Postgres has been around for a long time. It's coming up on 40 years. That's not young anymore. And this is, I mean, fairness, this is when we're counting Postgres, the old Berkeley project, which existed for a while before the PostgreSQL that we have today came out. But even with PostgreSQL, it's kind of old. Or is it really old? Or does that really just mean experienced? A lot of the things that we see and hear around are things that happened a long time ago in Postgres, or you know, that we go like, yeah, that's not really new. But throughout this time, and I myself got involved in Postgres, not back in the Berkeley days, but I've been in Postgres for a bit over 20 years at different levels. Started as a user, became more of a developer, and then eventually turned into doing Postgres on a professional basis. And to steal a quote that I think is originally very often stolen and misquoted, or misattributed, so I just go ahead and misquote it and say the reports of the imminent death of Postgres have been often repeated. Like throughout the time that I have worked with Postgres, at a regular basis, people have said, no, Postgres is dead. There is no future here. We can't get anywhere, right? Just give up, go away, start doing something else. And this started, so my first experiences with Postgres were back in the 90s, purely as a user at the time. And if you looked at what people were saying then about Postgres and about other things, are things like, you know, oh, the people are building, but like, this is just a hobby. You can't use this professionally. Nobody serious would ever use open source, right? And that was not just Postgres. They said that about everything. It's all, you know, shady hackers hacking around, like nobody professional deals with this. And again, this covered other things than Postgres, right? And even at the time, most of the internet as it was running on open source, but people just didn't know. There were a bunch of things running on Postgres back then. People just didn't know as much. But the argument that you got a lot was that you can't really use open source. It doesn't take you anywhere. And as you move through time, the next sort of big era and the next round of Postgres is pointless came through the .com days, which, I mean, yes, there was overlap. This started in the 90s, but we got the general idea, right? In the .com days, Postgres is too slow was a common argument. Postgres is too hard to use. Postgres doesn't have replication. Postgres has all of these features, you know, like foreign keys and guaranteed data integrity and all of those things, but nobody needs those. Nobody wants those. We should build that at a different layer. It shouldn't be in the database at all. And there are no providers out there. Like every web host will provide competing products. Nobody will provide Postgres. And in fairness, some of these things are perfectly valid points. Postgres was, relatively speaking, slow for the typical workloads we had at the time. I wouldn't agree that it was necessarily too hard to use, but it was different to use. It did have replication, it just wasn't built in. So that was harder to use. Integrity should not be managed by the app. That's just wrong. And there were fewer providers available at the time. Postgres just wasn't as popular, and that sort of fueled itself. And then as we moved on, the next step after .com, so we get into the, however you pronounce this, I don't really know, but you know, the beginning of the new century. What was the thing then? Well, I literally, and I heard this was around the time when I got involved in Postgres on a more professional basis, I literally heard people complain that Postgres is so cheap that it cannot be good. I don't, but yeah, you know, that's what they said. And there's nobody to support it. And the big argument that I heard a lot about in this time was that Postgres will die from the fact that it doesn't have funding. And what was mostly meant by that is that there was no venture capital funded startup based on Postgres until there was, right? But but at the beginning of the double O's, at least there weren't any that people knew of. And that in itself would kill Postgres. And it wouldn't be able to survive throughout this, right? And then we move on to the 2010s. And what happened in the 2010s? Well, in the 2010s, relational is dead again, right? Throughout, and I hear this from people who've been in the database industry much longer than me, that the number of times that the death of relational databases have been predicted is much higher than this. But again, in the 10s, we heard a lot of this because everything was now supposed to be either a distributed key value store or a document database, right? And relational is only legacy. All these old dinosaurs, whether they're open source or proprietary dinosaurs, they're still dinosaurs. They're all going to die. They're all going to go away. Nobody's ever going to use it. Okay, yeah, sure. And then as we move on, the next thing that we saw, still in the 10s, I guess, but towards the end, that people start talking about cloud and databases in the cloud and databases for the cloud. And that's one thing. But the arguments that I started hearing through that is now things that now that everything is in the cloud, nobody cares what database you use, which I kind of think it's an interesting point. What do you mean don't care? Like, the cloud is where you run things. It's not necessarily what you run. And they're saying all regular databases that are not purely cloud-based services are dying. There's a common thing here. They're all called dinosaurs. They're all legacy, and they're all going to die. And these things have repeated throughout the whole time that I have worked with Postgres. Again, starting as a hobbyist, going into more as a user, and then doing it on a professional level. These have all said, like, these things all come down. There are different reasons all over, and they're all come to the conclusion that Postgres is dead. Or at least, it's probably dead already. It just hasn't noticed it yet. So my question to you then is, did it happen? Like, is Postgres dead today? Does it appear dead? Is it kind of like the reverse of this, the Monty Python parrot sketch with a dead parrot? Kind of, a little bit like that. So I'll quickly zoom back to a time about 15 years ago. This may actually be slightly closer to 20 years ago. I don't remember exactly, but it's in the area of 15 to 20 years ago. I had a discussion about these things, around one of these things where everybody said that Postgres was going to die. They're never going to break into the enterprise market, and they're losing out everywhere else, and all of that is going away. And a good friend of mine and a senior Postgres contributor said more or less this at the time. He said, one day Microsoft will put out their own version of Postgres. And that's when we know that we won. And this was, back in the days when open source was still fighting Microsoft, when Microsoft was very much, Windows enterprise installations and open source is evil. And we had some terrible quotes coming out of the organization. A very different Microsoft than what we're seeing today. So back in those days, and the deal then was that, eventually even the mighty Microsoft will, buckle under and start talking about Postgres. So one day, Microsoft will put out their own versions of Postgres, and that's when we have won. This is on Microsoft's website today, right? This is azure.microsoft.com. I count 1, I count 2, I count 3 versions of Postgres from Microsoft. Not just one, right? They've had one version for a while. We're now up to, we have their slightly older single server, we have flexible server, and we have the Citus hyperscale, which is technically not a different Postgres. It's a Postgres packaged with an extension that turns it into a distributed database. So not just 1, but 3. So per the argument of this person from 15 to 20 years ago, that means we've won. That's pretty cool. I like winning. Doesn't necessarily matter whether we've won or not, but I think we can say from the perspective of our survival that we have won, right? Postgres is not dead. Postgres is not dying. Postgres is growing. And it keeps growing. It keeps getting into more places. How did that happen? How come throughout all of these years, all the predictions of the death of Postgres have failed? Why is Postgres popular today? Why are we where we are at today? Well, I mean, we can't argue the fact, yes, price certainly matters. Particularly, a number of years ago, one of the main arguments, like whenever I, as a consultant or as a training or whatever I did for my company towards our customers, price was always one of the arguments. It was always, we need to get away from, insert name of proprietary vendor here that is too expensive for us. Postgres is good enough, but it's cheap. Right? That was a good start. But if I look at where things are today, price still matters. Sure, nobody wants to pay more than they have to for anything. But it's nowhere near as important an argument as it once used to be. And I think that's key to how Postgres got to where it is, because we have a lot more arguments than just the price. And I think this is one of the important parts around Postgres. Postgres is based on a permissive license. It is a do whatever you want license. It is a sell whatever you want license. It is a package whatever you want license. It is a anything goes, almost. Like the restrictions that are put on you as a consumer, as a user of Postgres, are almost none. The restrictions that are put on you as a reseller or as a hosted platform provider, or anything like that on Postgres, are almost none. And this leads to not restricting our architectures, which I personally think is very important. I've seen throughout my years working with other products that far too often, when people are designing the architecture of the system that they want to build, they do it under the constraints of this server that sits over here, there can only be one of them, and it cannot have more than 2 CPU cores because it gets too expensive, or because then we end up doing this, or we can't use this particular feature because then we have to pay for the enterprise edition, or our support contract across our entire organization for other things get affected, and things like that. And the Postgres license lets you do whatever you want. You will never pay for Postgres itself, and you will never be told what to do. Now, you will be buying services around Postgres, whether it's support or hosting or anything, and they may add restrictions, they may add prices, they may add whatever they want. But that's at the service level. That is not Postgres itself. So having this flexibility has allowed people to do a lot of things with Postgres that they otherwise couldn't. And the other thing that I think is key to Postgres survival is that the project itself, at the core, it started from a very solid product. It has been solid for a long time, and it stayed true to its roots. Don't panic, don't do this. Oh no, you have to change to do it this way right now, or you're dead forever. That has come. The Postgres project had basically just ignored that and kept plodding along on the path that it was already on. It keeps adding features, it keeps improving things. It is a slow rate. Yes, sometimes it can be super frustrating. You cannot see a roadmap. You don't know what's going to show up in 2 years' time. But there is continuous progress that has just left us at a place like that. And yes, Postgres is still playing catch-up. There are still features in Postgres, or features in other databases that Postgres doesn't have, particularly when we're talking about big enterprise players. But there is almost always something chipped off in every version. For example, the upcoming version of Postgres that we hope to put out after summer will finally have support for the merge command, doing full-on merge. And some people will go, well, we don't need that. We have, insert on conflict and things. And no, we need it. It solves a different problem. There are still more things to do. And these are good for moving systems, moving people, and moving organizations from existing solutions onto Postgres. And we do see a lot of that. Another killer that I think for Postgres is developer flexibility. And I'm not talking about the developers who build Postgres. I'm talking about developers who are building applications that are using Postgres. Because Postgres is good at integrating new technology, at integrating things. They often come to Postgres before they come to a bunch of other places. These days, it hasn't always been true, but it is. If you look at the Postgres JSON support, it's very early on. It is very powerful. It is, in my opinion, significantly better than most other databases. Maybe not all, but we're talking relation now. Postgres range types is an extremely powerful concept that, sadly, I don't think anyone else has. They really should, because it is really, really useful. We have PostGIS as a great example of an external project that integrates deeply with Postgres to provide functionality that is really hard to find elsewhere and drives developer adoption. And the thing that is important through this, and the thing that Postgres has at least mostly done here, is integrate with the new technology, don't replace it. Right? you still have this solid core of a traditional relational database in the middle. You have your regular, integers and strings and whatnot, that everything works. And then you can just integrate these new things on top of it. And the way that Postgres does it is using this extension-based system, so that things like PostGIS doesn't even have to be built inside of Postgres. You can just plug it in and it will integrate to a deep level, whereas other things live directly inside of the core database. I think this flexibility is key to getting a developer mindshare, right? Yes, there's a large set of developers who will build everything through their ORM, but once they graduate from that and start doing more native database things, then this flexibility becomes a great value. And Postgres also comes with a deployment flexibility because it runs everywhere. You're hard-pressed to find somewhere where you cannot run Postgres if you want to. And this is an important flexibility for wherever you go. If you look at the existing cloud providers, Postgres runs on all of them. There are managed Postgres services on all the major cloud providers. There are managed Postgres services on most of the minor cloud providers. You can always run Postgres in a virtualized environment on a cloud provider. You can run it within whatever you call it, these automatic scaling features of the respective providers. It sort of just works. And having a system that integrates well with the operating system used on the clouds helps. Having the permissive license also helps because, for example, if you want your system to automatically scale up and down the number of replicas available in a system, that's kind of hard to do if you have to sign a new license contract every time you want to scale up, for example. So the flexibility comes back. It goes in. Obviously, a lot of people still run their stuff on premise. Postgres works fine there. It works in your traditional deployments, whether they're physical, whether they're VM. It integrates now. It's popular to run Postgres in Kubernetes or using whichever management tool on top of Kubernetes that people prefer. It does so with very few caveats. Right? It tends to sort of just work. Now, personally, I may not think that most of the people who run Postgres in Kubernetes really should not be running Postgres in Kubernetes because don't. Right? It's much harder than you think. But for some of them, it is the right choice. It's there. You choose where to run it, and that just works. And having this flexibility for deployments as well means you can run it locally. You can then move to the cloud. You can move from the cloud. You can move between different providers. As long as it's all Postgres, it just works. And this is an excellent way today to stay relevant in the marketplace because people want the ability to move. And yes, putting things in some of the systems that our big cloud providers provide today is like the worst kind of lock-in you ever saw. When Postgres got started and when a lot of the open source movement got started, the idea was we need to break free of the lock-in of the proprietary vendors, at the time, primarily Microsoft. And the kind of lock-in that a lot of people are building themselves into now on big cloud vendors is often worse. But if they're running Postgres on the big cloud vendor, that lock-in suddenly becomes much, much smaller. And I have numerous clients who have chosen Postgres partially for that very reason, who've said, we're okay with this lock-in because it runs Postgres, because we can move our stuff out if we want. Whether they're ever going to do that, sure. But having the ability to do that is an important part to be able to move these things through. So where does that actually leave us? Where are we today? And I'm going to bring in another quote that came up recently, which is, Postgres has emerged as the API for operational databases. This was part of an announcement from Google, from the Google Cloud Spanner team, where they've taken their decisively non-Postgres database, Cloud Spanner, and added a Postgres compatibility layer on top of it, basically. Because that's what their customers want. Their customers want to speak the Postgres protocol. They want their database to look like Postgres. They don't want it to be separate. And I think reaching this point where one of the major vendors in the market just called our product basically emerged as the standard API is a good way to define that you're relevant in the market. And in the end, where we are at is nobody needs Postgres. And that's the point. Right? Nobody needs Postgres. There are other databases. You can do everything else, where there are very few products in the IT market that anyone needs that really doesn't have any competition. There's a lot of competition in the database space. But what we're seeing more and more today is that everything runs on Postgres. It may not run on standard Postgres. It may run on, AWS Aurora or Citus for scalabilities. It may run on this cloud spanner, but there is Postgres somewhere in more and more products, and it runs in the back end. Nobody sees it. It's nice and quiet, and it chugs along and it works. But the reason everything runs Postgres is everything runs Postgres by choice. And I think that's important. Nobody forces anyone to choose Postgres. People choose Postgres because they want to, and it still grows. That's being relevant. And it really is the flexibility, in my view, that has brought Postgres to this point and that keeps us at this point. It is the flexibility for everybody, right? Whether you're a dev, whether you're DevOps, whether you're pure ops, whatever, the flexibility of Postgres to fit in and adapt to what your organization needs is what keeps Postgres relevant. And it is flexible for the whole organization. It is not just for the technical people. Everybody understands the importance of deployment flexibility, of being able to have an agile organization that can change, that can move and things as it is necessary. So it's really Postgres for everybody. It's not just flexibility for everybody. Postgres fits in to solve the problem of getting flexibility for a lot of other things. Postgres can be used as an integration point. Again, a way to stay relevant. Everybody talks to Postgres and exchanges messages or exchanges data through Postgres. And I see a lot of more people wanting it to do that through Postgres than they do through a lot of the competing products these days. So that's going to be my main takeaway from this. Postgres for everybody is really the way for Postgres to be and to stay relevant in the marketplace and to be, as I say, more relevant than ever. This is what got us there. This is what will keep us there. So with that, I'll say thank you very much for listening in, whether you happen to be live or whether you're watching this later. If you are watching this live, and I know Claire said earlier that you can all join us on the Discord. Sadly, the Microsoft Discord server is not in the mood of verifying my account right now, so I can't get in. Sorry about that. But at any time, you can just reach out to me on Twitter, for example, or drop me an email if you have any further questions on this one. And with that, I think, do we have time for if we have any live questions to go with right now?
We have time for a couple of questions. I know that.
Do we have any?
I actually didn't check the Discord server because I was busy tweeting about your talk. I loved it. I have questions for you about how much this gets discussed among members of the Postgres community, this assertion that Postgres is dead or Postgres is going to die, which sounds like it's been coming up for a very long time now, right? So is it something that you kind of joke about over dinner, but then just focus on doing the work, or does it ever get to be a distraction?
I think that's a pretty good summary. It's certainly something that's every now and then joked about over dinner. And obviously, I mean, people take it seriously to a level that you look at it and see, okay, so these people think we're going to die because of X, so can we fix X? Right, for some things. As an example, we saw a big push towards the document-based databases, for example. Well, Postgres that was the time when Postgres learned, well, let's add the ability to do document database inside of Postgres, and again, with this flexibility, combine it with a traditional relational database and run both at once. So the group is certainly paying attention to these things, but some of them, some of them are just ridiculous. But you have to, and they just stay as the dinner jokes. Whereas for the rest, sure, there is value in the input as well. So certainly people listen to that input as well as other input.
Well, I certainly got a kick given that, we're hosting this event from Microsoft, you including the Microsoft quote, which I took a picture of because I wanted to, although I think I have a copy of your slides, don't I? So I'm sure I could look it up online, but I want to read it out loud again. Let's see, where is it? One day Microsoft will put out their own version of Postgres, and that's when we have won. It's kind of cool. And I think
I like the quote, and I really like the fact that we got to that point.
Yeah, and I think that was back in, was it 2018 that Azure Database for Postgres, the managed service, first came out. And I wasn't at Microsoft at the time because I joined as part of the Citus acquisition, but pretty darn cool.
Yeah, and now there's three.
Oh, 3 deployment options, you mean, in Azure
Yeah, I mean
Database for Postgres?
they're each, as with all of these managed services, whether it's Azure, AWS, or Google, they're ever so slightly forked versions of Postgres to adapt to the cloud platform. So technically, they are actually 3 different versions of Postgres, though they're designed to look the same to the developer.
Okay. There is a question that I'm getting on the chat that pivots us in a different direction. And you mentioned Kubernetes and running Postgres in Kubernetes before. So I feel like this could be a rat hole that takes us into a 15-minute discussion, which we don't have time for. But I'm going to ask it anyway, because maybe you have a short and succinct answer. Otherwise, we'll end up having to take it on over in the Discord server once we get your login fixed, which we will as soon as Aaron wakes up. He's asleep. What can be the caveats in running Postgres in Kubernetes? This is from somebody who is studying alternative ways to scale out their monolithic multi-tenant app, and they want to know more. Postgres
in general, I mean, obviously, yeah, as you say, we can easily spend 20 minutes on just that topic, but most of it comes down to simply complexity, right? Kubernetes is very complex. It is relatively easy to deploy and scale stateless services for it, but to scale and properly manage a stateful service, in particular one that you need to tune for performance of the individual node, can be very complex in Kubernetes. If you have lots of instances, it pays off. But I see a lot of people who have, we only have a primary and a standby setup and we want to run it on Kubernetes. And if you only have that, like, you're going to be paying so much more in complexity than you ever get back. You have to get to a fairly large number of instances in your scale before you get payout for the complexity to manage it, I think is the summary. And I'll be happy to discuss more details around it later once I figure my way into the Discord.
Okay, sounds great. I want to thank you. I am so happy you said yes and that you joined us today. I think your talk was really interesting, particularly for people who've only been involved in Postgres for a couple of years. You've got that historical perspective, and thank you very much. Really appreciate it.
Thank you. And I'll be curious to see if the person who gave me that quote many years ago remembers it and if he was actually listening into this stream. So if you did, you know who you are. Just give me a ping. It'll be fun to know.
All right.
Thank you very much for having me. And,
thank you, Magnus.
Let's look forward to the rest of the day.
Appreciate it. Thanks. Moving on to our next speaker, although it's always hard to leave one and move on to the next. Our next speaker today is a developer, and he's also a technical lead, and his focus is on databases and software design, and his name is Haki Benita. Welcome.
Hi, Claire.
Did I say it right? Did I say your last name right? We didn't practice it.
Yeah,
oh my God, it's wrong.
No, you said it correctly. I made it
did?
easier for everyone because nobody can actually pronounce my real name. So Aki is like an alias.
It's okay. Well, I got to say, other than people from Italy, most people mispronounce this last name that I married into. So names are tricky.
Exactly. Names are tricky. This is why we all have handles,
Exactly. So you're here today to talk. The title of your talk is Lesser Known Features of Postgres. You've obviously given similar talks in the past, and you've written about this topic too. I think it landed on the front page of Hacker News, didn't it? Or the very top of Hacker News. So I know it's popular. I know people want to hear from you. So I'm going to step back stage and let you take it on from here.
Thank you very much, Claire. Okay, so hi everyone. My name is Haki Benita, and as Claire said, I mostly am interested about databases and web development and software design. Aside from being a DBA, I'm also a software developer, so I get this perspective from both worlds. But I usually like to say that I'm a DBA that knows how to develop applications and not the other way around. So today I want to talk about a few lesser known features in PostgreSQL, but I would say this: I'm not going to talk about new lesser known features. I'm going to talk about lesser known features in general, meaning that even if you're not working on the latest or on a latest version of PostgreSQL like 13 or 14, there is things in this talk for you. I have features here that are in Postgres from Postgres 10, and not a lot of people know about them. So some of these features are actually undocumented, and when I will show undocumented features, I'm going to add a note because you should be careful with undocumented features. So let's start. I'm going to go fast, and hopefully we'll make as much as possible. So insert on conflict, also known as the observe command, or if you're coming from a different database, you might know this as merge. It's a way of syncing data between two tables. Let's see an example. Say that you have an employees table, name, department, role, and the salary. And now you want to sync new employee data into the employees table, right? So if we take a look at the data, we can see that George is an existing employee, and we just updated his salary. And Jane is a new employee starting in the R&D department as a developer. So now we want to get this new employee data into the employee data. We want to sync it. This is a very common thing to do in ETL processes or data migrations and so on. So if we want to do that in Postgres, what we can do is we can use the insert command, just like you are familiar with, but we might have conflicts. Remember, George is already an employee, so we can't insert George again into the table. So Postgres provides us with an on-conflict clause that we can tell the database what to do in case of conflicting name. So in this case, in case of a conflict on the name column, we want the database to do an update. So if the database encounters a row that already exists in the table with the same name, it will update the department, the role, and the salary from the table we are inserting from. In this case, new employees. So this is very useful, and this also assuming that name is unique, okay? So if we look at the output of this command, we can see two rows. The first is George and Jane, and Postgres tells us that two rows were affected. But the question now is, how many of these rows were updated and how many were inserted? Okay, so if you have an ETL process or a data migration, this might be information that is useful for you for logging and stuff like that. So I want to show you a little trick of how to achieve this. So this is using a system column that I'm going to explain in a bit, but I haven't found much reference to it other than that. So be careful with that. You can use that for logging, but maybe not something that relates to the actual business logic of your the process that you are implementing. So a possible solution. We take the exact same command that we ran before, insert and on conflict do update. And if you'll notice at the bottom, the highlighted row, we want to return the data, return and a star, Cetric. We return all the data that were affected by the query. And we also add an expression, xmax equals 0. Okay, so if we look at the results, we can see that now we have another column called inserted. And this column says that for Jane, the row was inserted, and for George, the row was not inserted, meaning it was updated. So now we know how many rows, which rows were inserted and which rows were updated. And we can actually aggregate on this results to produce a useful log. So how is this trick working? Remember that we use the special column called xmax. So xmax is a special identity column in Postgres. And if you're not familiar with how Postgres works, when you update a row, Postgres behind the scenes deletes the current row and inserts a new one. So xmax is the transaction ID of the deleting transaction, meaning if we executed an update, then we are going to have the transaction ID of the deleting transaction. However, if we inserted a new row, then there is nothing to delete and xmax is going to be 0. So this hack is building on this behavior by Postgres and calculates an expression that lets us distinguish between inserted and updated rows. Very cool, very useful. I used it several times myself. So next up, sleeping. Anybody with babies at home has to appreciate sleeping. So why would you want to sleep? There are many reasons that you want to sleep during the execution of a program. Sometimes you want to do some benchmarking. Sometimes you want to do testing, maybe throttling some to control access to some resource. Maybe you have some while true. Maybe you're just doing some benchmarks. There are many ways to sleep and many reasons to delay the execution of a program. So if you ever had to sleep in Postgres, you probably used PG sleep. It accepts a number, which is the number of seconds you want to sleep. If we set up timing and select PG sleep 3, we can see that the execution took 3 seconds. So for 3, it's not that bad. But what if we need to sleep for a longer period of time? So in this example, we want to sleep for 255 seconds. So how long will this function sleep for? So before you take out the calculators, if you want to be a good friend, if you want to be a good developer, good teammate, you can change it to write it like this. So 4 times 60 plus 15. This makes it a bit easier to identify that you want to sleep for 4 minutes and 15 seconds. But if you want to be a very good friend, you can actually use PG sleep 4. This is a relatively new function that accepts an interval. And I don't think it gets any simpler than that. So PG sleep for 4 minutes and 15 seconds. That's basically English. Okay, what happens if you want to match against multiple patterns? Let's look at an example. Say that you have a users table and you want to find all the users that use a Gmail account. So that's a fairly straightforward query. You just query from the users table and you match against strudel.gmail.com. You can use the percentage sign to match against everything. So this expression will match against anything that ends with gmail.com. So that's easy. But what if you also want to find users that have a Yahoo email account? So now you add an OR condition with 2 patterns, and your predicate gets a bit more tricky. The more pattern that you add more OR conditions, and the predicate gets more and more complicated. So there are a few ways you can make this a bit more readable. Let's see some of them. So the first approach you can take with Postgres is using the similar to operator. This lets you provide a pattern, and the pipe operator can match against multiple patterns. Okay, so this is using POSIX regex, and it's pretty clear. Another option is to actually use regular expressions. In this case, there is something tricky that you need to know. The period matches against any character. So if you actually want to match a period, you need to use an escape character, in this case, the backslash. So that's also another way of approaching this problem. But another very cool way in Postgres, and if you're using Python, you might be familiar with any and all. So Postgres also provides a way of matching against an array of patterns. So this condition will match email against any of the provided patterns. So what is the benefit of this approach over the other approaches? If you are executing this query from some host language like Python, this is an example using scopg, which is a driver for Python, then you are probably using bind variables. So it's much nicer to be able to send a list of patterns instead of just a big pattern. So in this case, you can see that we bind an array called patterns, and we actually provide a Python array as a bind variable to this query. So that's pretty nice. Keep that in mind the next time you need to bind or match against a list of values from a host language. Okay, generate reproducible random data. This, I know that it sounds strange. Why would you want to reproduce random data? And if it's reproducible, why is it random? I'm going to try and explain. So let's say that you are giving some code review to your fellow developer, and you think that some of his code is not 100% optimal, and you want to demonstrate to him why. So you set up this sample table, you populate it with a lot of random data, and then you execute some queries to make your point. That's fine. And then you send your fellow developer the script, okay? And he tries to execute it on his workstation, and he gets different results. So that's now good. That's very confusing, okay? So let's see an example of how we can make my fellow developer produce the exact same data for testing and benchmarking. So this is an example of how you produce different types of data types in Postgres using the random function. You have a random float, integer, and date, and you can see the results below. If I take the exact same query and execute it again, I'm going to get different results, right? Because it's just random. But if I want to make sure that when I re-execute the same script again, I'm going to get the exact same results, meaning reproducible random data, I can use setSeed. setSeed accepts any value between 0 and 1. And when you use setSeed at the beginning of the session, consecutive calls for random are supposed to produce the same values. So if you actually have PSQL open in the background, you can actually setSeed 4050 and execute this query, and you should get the same values that you see here in the presentation. Okay, just to illustrate, if I set the seed and call random to produce 2 random floats, and I take this to a different console window or even execute this on my server, I'm going to get the exact same results. So this is very useful if you are demonstrating something, benchmarking something, testing something. I know that usually when I write in my blog and I want people to be able to reproduce my results, I always include a setSeed at the beginning of the script. Okay, so now we have the feature with the best name ever, $quoting. And this is what it does. So let's say that you have this string constant, in this case, John's Pizza. This is just the name of a business. And you might notice that John's Pizza has a quotation mark right before the S. Now, if we want to include that in the output, we need to escape that. In the case of a single quote, I need to escape it with another single quote. Another type of annoying characters that you need to escape are new lines and backslashes. So if you want to add long strings or complicated strings in PSQL or in SQL in general, it's pretty annoying. So I didn't know that for a long time, but there is a solution for that in Postgres, just like in any other language. So another way of writing string constants is using what's called $quoting. If you look at the query that you see on the screen, you might notice that you have $2 signs at the beginning of the long string with new lines, and then you have another $2 signs at the end. So everything between these $2 signs is a single string. You can also notice that we have single quotes and double quotes and many different type of characters and new lines and so on. And everything between these $2 quotes is a single string constant. So that's pretty useful. No need for escaping. Now let's make this harder. What if I actually do want to include the $sign in my text? In this case, I want to add a string constant with a JSON value with a tagline for John's Pizza saying best value for your $sign. Okay, so if I use $sign, Postgres might get confused and terminate the string just at the end of the tagline. But I don't want that, so I can actually use a different token. So in this case, I just made up a token called JSON, and everything between $JSON, $sign until another $JSON, $sign is a single string, and you can see the output below. So that's also very useful. One of the best uses I found for that is when you have some big JSON file and it actually makes more sense for you to process it in the database. You can just cast this to JSONB and continue processing in the database. This is very useful. And I know that you talked about it in the previous talk, but Postgres is doing an amazing job with JSON types, where it came to a stage where it actually makes sense sometimes to paste large JSON data into the database just for processing using Postgres. So this dollar quoting makes this especially easy. Okay, so that's a fun one. Let's talk about how to prevent setting the value of an auto-generated key. So if you are old enough, you are probably familiar with the serial data type. If you have a primary key in the table and you want to populate it from some sequence, you might define it like that: ID, serial, primary key. Okay, so Postgres in this case will create a unique constraint and also create a sequence behind the scenes to use when you add new sales into the sale table. So this serial data type is very unique to Postgres. It's not standard SQL, and it has a lot of known problems, which I'm not going to talk about. So starting at Postgres 10, the team decided to softly deprecate it in favor of identity column. And this is what it looks like. Instead of writing serial, you write generated by default as identity. So this works very similar to what you know from a serial data type, but it's SQL standard and it solved a lot of the problems of serial. But let's consider this scenario. Say that you are adding a new cell to the table and Postgres uses the sequence, populates the ID with the first value 1. Great. Next, you add another cell into the table, but this time you provide a value for the ID column. You provide the value 2. The statement succeeds and you have 2 rows in the table. Next, you try to insert a value into the sale table, but this time you do not provide a value for the ID column and you get a unique constraint violation. So why did it fail? When you added the first row, Postgres used the index and set the value 1. When you added the second row and provided the value 2 for the ID column, the sequence was not used, so it was not advanced. In the third command, when you did not provide a value for the ID column, Postgres used the index. The value happened to be 2, and you got a unique constraint violation. So if you think about it, it doesn't make a lot of sense to set values for auto-generated keys. And as we saw, it can cause a lot of mess. So is there a way to prevent that? Is there a way that we can tell Postgres, stop, do not let the user set a value for this column? And actually there is. Instead of defining the identity column as generated by default, we can say that it should be generated always. If we try to do that again, provide a value for the ID column, we are going to get an error. Now, Postgres is nice enough to tell us what we need to do if we actually do want to set a value for this ID column. We need to use this option called use override system value. And this is what it looks like. So I think that's a good compromise because it allows you to set values explicitly, but you have to be very aware of the effect on that, on the potential effect of that on your system. Okay, so let's talk about constraints. So constraints are good. Constraints are great. Use constraints. Constraints keep data clean and reliable, and you should always use constraints. What I do like to say about constraints is that constraints are very easy to remove, but are very hard to add to existing tables. If you did find yourself in a position where you had to add constraints to an existing table, this can be a bit challenging. So let's look at an example. We have a very large orders table and we want to add a check constraint to make sure that the price is greater than or equal to 0. If you look at the timing, you'll see that it took 10 seconds in which the table was locked, okay? So that's a bit of a problem. So is there a way to make this a bit better? There is. If we take a step back and look at what the database is actually doing when we are adding new constraints, it operates in 2 stages. The first one is to add the constraint to the table and enforce it for new rows. And the second stage is to validate this constraint for all the existing data in the table. So what if we can actually split this process manually? So you can. If you want to add constraint without validating existing rows, you can use this command, table add constraint and add not valid. Notice that it's very, very fast because it's only adding the constraints and starting to enforce it for new rows. Okay, so the next step is that we want to validate the constraint for past rows, and you can do that with table validate with the name of the constraint. I feel like I'm out of time, right? No, I think that I have a few more minutes left. I'm just going to go until they will shut me down. I have 3 more minutes. Great. Okay, so I won't talk about synonyms in PostgreSQL because that's very long. So you can read the article because I do want to focus on the PSQL tips because they are very cool. So this is one of the things that I found, and ever since I've been using it all the time. Let's say that you have this query on an employees table and you want to count how many developers, managers, and whatever you have in each department. So that's a very nice table with a very standard query, but a pivot table would be very, very useful for this type of information. So what you can do, and check this out, you can just use this command /crosstab view, and Postgres will just transpose the last results into a pivot table. So that's amazing. I don't know how many of you are using PSQL on a daily basis, but I do a lot, and that's amazing. You can actually control crosstab view with arguments if you want to transpose it in a different way. So crosstab view works on the last query results, and it uses the first 2 columns. So that's super great. You can use that. And my last tip, probably the most useful one, is copy. If you ever had to get data in and out of the database, you're probably familiar with the copy command. What you probably don't know is that there are 2 variations of copy. You have the copy command, which is executed on the server, and you have the /copy command, which is actually a PSQL command with a very similar API, only it's executed on your computer, on your client. So what you normally want to do is you want to use the /copy PSQL command because you want the data, you want the exported file on your workstation. The problem with /copy is that it does not support multi-line SQL. If you have a very big report, you can't use copy because once it detects a new line, it throws a parse error at you. But there is a trick you can use because while /copy does not support multi-line, copy does. So we can combine a few things together to be able to export multi-line queries to our local workstations. And this is how it goes. First, you use the copy command. Remember, that's the server command. Now, instead of streaming the results to some directory on the server, you can tell Postgres that you want to stream the results to the standard output to std out. Okay? And then you can combine that with the /g command, which is a PSQL command that writes stat out to a local file. So this is how we can use copy and /g to produce the results of a long multi-line query to our local workstation. In this case, I use the CSV format. So this is it. If you like these tips, you can find the original article here at the top, lesser known Postgres features, as well as other similar features on my blog. And you can find me in all of these places, Twitter, get an email when I subscribe, when I publish something new, or if you're old-fashioned, you can send me an email to this address. And this is it. I hope you find these tips useful. Any questions?
Yes, that was fabulous. Thank you so much, Haki. I think you gave us a little teaser. There's a bunch of people chatting on Discord now saying what they really want to hear about are synonyms in Postgres. So it's the part you didn't talk about.
I know what they want to hear about synonyms in Postgres because synonyms does not exist in Postgres.
Got it. The other quote I wanted to read to you is like one of the smartest people I know basically said that he only knew one of the things that you talked about. So, and he's super knowledgeable in the space. So I guess these are lesser known techniques. How do you come up with them? Why do you know these things when others don't?
I'll be honest with you, many of these features I came to find when I actually had a problem that I needed to solve. And some of them I found by just occasionally reading the documentation. You would not believe how many games you can find the documentation. A lot of good stuff there. It's a recommended reading if you are bored or have some time.
Now, which of the lesser known features have you found amongst all these things to be the most useful for you?
Great question. Aside from the copy command, which was an absolute lifesaver, I think that dollar quoting was the most useful, simply because it's so obvious that there's something like that should exist in the database. And yet I spent so much time manually escaping strings in Postgres. And this was definitely a huge time saver for me.
Yeah. And I guess at the end of the day, time is probably what we all care about the most. Before we go, because it's about time to hand over and move on to the next talk, is there a new feature that you are most excited about?
Yes, absolutely. So at the beginning of the talk, I talked briefly about using insert on conflict, which if you ever written ETL processes or data migrations, you probably use all the time. So there is a limitation to on conflict at the moment. You can only upsert when you have conflict in a unique constraint, and you can only handle one unique constraint.
Okay.
So in Postgres 15, there's a new command called merge.
Yes.
And merge is supposed to solve both of these problems. You will be able to handle conflicts on non-unique columns, and you would also be able to handle multiple conflicts on different fields. So I'm very excited about that. I think it will be immediately useful for me.
Well, and I think the PG15 beta candidate release, didn't that freeze happen last week? So the folks who are Postgres committers are pretty exhausted still, still recovering from the whole experience. And I guess beta is going to be released for testing and whatnot in May sometime. That's what I'm hearing, at least. Okay, so I want to thank you very much for joining us and being part of CitusCon. And I hope you keep blogging and sharing all your tips, especially as you come up with new ones.
Thank you so much, Claire. It was great. I'm going to hop on the Discord channel and answer some questions.
Awesome. That would be great. Thank you, Haki.
Thank you.
All right. So next up, we have some co-presenters. And I'm bringing up my schedule here so I can make sure that I get everything properly correct. These two senior software engineers are both from Algolia. Antoine Hemery, and I'm not sure if I got your last name right. Oh, wait, I'm going to introduce you in the order that you're standing. So Matthieu Dumont on the left, and Antoine, is it Hemery? Close. Oh, come on. Tell me how it's really pronounced.
Hemery.
That's good.
Yeah.
All right. So they are here to tell a customer story about running their application on Postgres and on Citus as well, and the zero downtime migration. And I will let the two of you tell your story. I'm really excited that you're here, and you're joining us from France, I believe.
Yes, Paris, France.
Okay. Well, welcome, and let's hear it.
All right. So hello everyone, and welcome to our presentation. So today, Matthieu and I, Antoine, will present you how we migrated from Citus Cloud to Azure Cloud, the 5 terabyte database, Citus database powering Algolia Analytics API. But first thing first, a quick introduction of ourselves. So hello, I'm Antoine, and I've been working at Algolia for 3 years as a software engineer in the search team.
And hello, I'm Matthieu. I'm also part of the search team with Antoine, and I've been working as a software engineer at Algolia for the past 7 years.
So today's agenda. We'll first give you a little bit of context regarding the usage of Citus at Algolia and how we leverage it for our analytics API. We'll then talk about the migration itself, how we prepared it, how we tested it, and how it went. We will finally give you advice and takeaways to help you navigate such a project.
First, a little bit of context. For those of you who might not know Algolia, we're a search as a service company. We provide an API that is used by many websites and mobile applications to power their search and discovery experiences. As you can see on this slide, we process a significant amount of requests, more than 100 billion per month for more than 10,000 customers. All customers need to have a concrete overview of what all of this traffic represents. This is why we have an analytics dashboard which aggregates data about this search traffic. Here you can see a screenshot of this dashboard. For instance, it includes the most popular searches, the most popular results, search trends, and quite some more. Those give insights to our customers to help them, in turn, improve their search relevance. Under the hood, here you can see a simplified schema of our analytics pipeline. At the top left, a user searches. This generates some logs. Logs are aggregated and sent to a remote storage. Whenever the storage receives a new log file, a message is added to our queue, and our writers read those messages and compute aggregates that they store inside our Citus database. Then, on the bottom left, our customers contact our analytics API. It itself queries our Citus database and computes aggregates on top of the aggregated data inside the DB. This pipeline actually exists in two different locations. We have one in the US and one in Europe. To give you some perspective about the migration we're talking about, in practice, those two clusters represent 5 terabytes of data spread over 20 machines. Now, let's talk a little bit about why we needed to migrate this database. Historically, we've been using Citus data as managed offering called Citus Cloud. Those managed instances ran in AWS, but understandably, after the acquisition of Citus data by Microsoft, this offer got discontinued and its end of support was coming. On the other hand, the Citus team had been working since the acquisition to propose a similar offer in Azure called Azure Database for PostgreSQL hyperscale silos. So it's almost as if they wanted to make us struggle with this presentation. To keep it short, we will actually mostly call it hyperscale Citus. After some discussion with the Citus team, it appeared to be the right replacement for us. One of the big advantages here was that since they had ownership on both systems, they could handle part of the migration process for us.
So as Matthieu just mentioned, the migration was necessary for Algolia to ensure a continuity of service for our customers. To achieve this, we set ourselves multiple goals to provide a seamless migration for our customers. We had 3 main goals: stability, uptime, stability, and pricing. So today at Algolia, we have more than 11,000 paying customers. A majority of our customers rely on the Analytics API to take strategic decisions for their businesses. To do so, they either use the dashboard or directly request the API to build homemade analytics reports. In practice, this usage represents a 24/7 load of 100 requests per second. As a result, we wanted a minimal downtime migration to reduce as much as possible the inconvenience for our users. Now let's talk about stability. As engineers or people working in the tech industry, we are all too familiar with the Murphy's Law, which states that anything that can go wrong will indeed go wrong. So the analytics project has been stable for years prior to the migrations. And as it's a strategic product, we wanted to lower the risk. To do that, we reduced all the possible changes. Firstly, the infrastructure changes, like the Postgres versions, the Citus versions, the size of the coordinator node, and the amount of worker nodes. Then we reduce the code changes, like no new feature, no experiment, no library update. It was kind of a code freeze. The reason was that any change to the code base might introduce a sneaky bug that could trigger in the middle of our migration. That's why we reduced all the possible changes. Last goal, but not least, was the pricing. We didn't want to increase the cost of the analytics infrastructure, so you can see on this slide the very complex algorithm we use to evaluate it. Now let's talk about how we prepare that migration. Same as before, the preparation can be cut in 3 main topics: checking the provider capabilities, writing a migration playbook, and finally testing the new formation.
On the provider capabilities side, we started with the basics. First, we looked at the hardware, CPU, RAM, disk performance. Azure had comparable machines, so everything looked good on this side. Then we looked at the software. We started with the supported Citus and Postgres versions. All good there, we could migrate without having to bump any of the major versions. Also, Citus Cloud and Hyperscale Citus are both managed Citus instances, where we don't have access to super user restricted configurations, features, or extensions. So we had to check with the Citus team if those would be correctly ported over. It was the case. Finally, in AWS, we used ZFS for its compression capabilities. However, this file system is not supported in Hyperscale. So we first checked whether it would be a problem for the migration itself, and all good on this side. However, we had to keep in mind that we needed more disk space on Hyperscale. In our case, it was 2 to 3 times more. At a higher level, we also checked a few infrastructure and security-related topics, the provided SLA, whether we could host those databases in the same regions as we used to, and we double-checked the security and confidentiality features that we needed. Finally, we wanted to make sure we could operate this database in the long term. As you will see in this presentation, a good monitoring setup was primordial for us. Also, we needed to know which tools were available to us in case of an issue or a disaster, which is why we checked both the backup system and the support routes. The second important step we took was to create a migration playbook. This playbook, of course, included the different execution steps of the migration itself. So communication, for instance, synchronization steps we had to take with Microsoft, notifying our own teammates on Slack, etc. But it also included terminal commands to run and UI interactions to do. But we didn't stop there. We also added two things that felt necessary for us. First, we added some verification steps at multiple stages of the process. This allowed us to make sure that no silent failures went undetected. Second, we had a recovery procedure that we could use at any point in time to revert and roll back to our previous instance in case anything went wrong. One note we have on this topic is that the process was iterative. We created the playbook early, even though at this stage we weren't yet sure about all the steps we would need to take. This allowed us to test commands and UI interactions as we went in isolation. Then every testing step brought us closer to the ideal and final scenario. When we started working on the playbook, our tech lead asked us, but why bother this much? We wrote this playbook so that anyone, even with zero knowledge of the project, could run it. There were multiple advantages to this approach. First, it could be reviewed by way more people, which helped us validate the approach. Second, it gave some context and operational knowledge to people in our team who weren't familiar with the analytics project. Third, it allowed us to make sure that we didn't forget anything, like stopping a cron job, which almost happened to us. And fourth, making it mechanical let us way more mental space to think about the unexpected things.
So now let's talk more about the testing strategy itself. But before going any further with this part of the talk, we have a spoiler alert with Matthieu. And that will be, please avoid biases at all costs. In fact, at Alicja, we have a huge bias towards read performance, as low response time is a key feature of our search API. So of course, with this bias, at the beginning of the migration, we thought that we would have issues on read, but all our issues happen on write. Our second advice, which comes along with the first one, is please test the whole system and don't assume that the part will not break, because it might for multiple reasons. So when we began the testing, we only had the initial pipeline, which you can see on the slide. The goal was to duplicate it and replace the Citus Cloud DB by the hyperscale one. With the help of the Citus team at Microsoft, we created an hyperscale DB from existing Citus Cloud backups. At that point, we had a fully replicated hyperscale DB in Azure. On our side, once the DB was replicated, we just wired the duplicated services to this new instance. With all those steps done, we were all set to start testing. We then started the writers and began to monitor the performance. And we got some bad news. So as you can see on the graph, when we plug the write system to hyperscale, we directly notice a huge difference of timing percentiles. The Citus Cloud instance is in green and the hyperscale one is in red. Unfortunately for us, the difference was not good, it was a regression. And a fairly big one. It was twice slower, taking twice as many resources. Matthieu and I were expecting identical performance because in the end, we had an ISO setup. That's why instruments are important to driver migration. They help you spot when something is off. Thing is, your instruments have different precision. With this graph, we identified that the write were slower, but we had no idea why. So to figure out the root cause, we had to use finer instruments. So with Postgres, when you have a perf issue, what you can do is to audit the pg_stat_statement system view. For those who don't know it, it's a PG module that tracks the performance of the query being executed on your DB. With the system view, we were able to determine that the create_rollup store procedure on hyperscale was slower. In fact, it had a mean execution times 2 times bigger than the Citus one. Like before, at that point, we had identified where the problem was, but we had no idea why it was slower. So to figure out why, we needed an even finer instrument. And one of the finest instruments you can have to debug performance problem on the DB are the query plans. As you can see, we run the explain analyze command on both formations to compare their respective performance. With that command, we confirmed that the write query was indeed slower on hyperscale. We then analyzed in depth the query plans and found that for some reason on the new formation the JIT was triggering, whereas it didn't on the previous one. For those of you who don't know it, JIT stands for just-in-time compilation. On its short, its role is to optimize specific queries at runtime. In our case, the JIT was considerably slowing down the execution for this query. After looking deeply into the query plan, we realized that the JIT didn't respect a configuration option we had set. With all this information, we now got an idea of what was causing the regression. But to confirm our assumption, we disabled the JIT on hyperscale to check whether or not it was the actual reason of the regressions. And this time, we got good news. It turned out it was indeed responsible for the regression, but Matthieu and I are skeptical people. So to be 100% sure, what we did is that we let the write pipeline run for a few hours to compare the performance of hyperscale and Citus. And in the end, as you can see on the slide, we were quite happy with the result as we got almost ISO performance in terms of number of rows ingested and latency. However, those slow queries weren't the only problem we got with Matthieu. On one of our formation, we got this surprising error message in our logs. That error was quite surprising for us as our system is designed to only have unique keys. So we realized that somehow the index got corrupted. But as before, we did not know why, so we had to dig a little bit. This time, we found the response by searching online for people encountering a similar issue. And it turned out that the libc was responsible for that error. For those who don't know what the libc is, it's a standard library used by most programs, including Postgres. Then now you might wonder, why the libc? And we are going to answer, beware of the libc. Because identical Citus and Postgres version don't mean identical behavior. Indeed, Postgres rely on libc to compute the UTF-8 collection used by the indices. And unfortunately, in our case, the libc was different on Azure, leading to this erroneous behavior. Thankfully, we spotted their quirk before the migration. We could then craft a recovery procedure in case that happened during the migrations. The trick was to perform a simple reindex of the table, and as you can guess, it's better to know it in advance. As a final warning regarding this issue, the latter isn't migration specific. For example, it could happen on your production database if your providers or your infra team upgrade the operating system or the libc on the machine where your Postgres is running on.
As Antoine mentioned, every issue we had were on writes, so things went quite smoothly on the reads. Still, here is a quick overview of how we tested them. First, with the ISO setup we had running, we logged the 10,000 longest API calls our current instance received over a given time frame. We then replayed those on the new instance. As you can see on this graph, we got results that were similar enough for us to feel safe testing further. To do so, instead of duplicating the traffic as we had done before for the writes, we did something terrible and we tested in production. While in general this is something that we avoid as much as possible, it felt like a good option in this case because it allowed us to test part of the migration playbook I described earlier. The way it worked was simple. As before, first, the Citus team created a hyperscale follower of the Citus Cloud instance. But contrary to our write testing, here we waited for the instance to be completely caught up with the live instance. Once it was the case, we promoted the hyperscale instance to become autonomous. At this stage, the data wouldn't change anymore on this new instance. Our customers are mostly looking at historical data over some days, so serving stale data for a small amount of time in our analytics pipeline is something that we can afford. As a result, this is why we simply switched our read traffic to target the new hyperscale instance for 1 hour. During this time, we monitored our monitoring metrics, which you can see on this slide. Can you spot when we did the switch? Because we couldn't. With those tests out of the way, we felt ready for the migration itself. We first started with our European cluster. Because it handles only 1/5 of the data, a failure there would be less dramatic. So first, we crossed our fingers and then, started the live conversation with the Citus team at Microsoft. They were the ones doing the main replication of the database, and we needed to coordinate some actions with them. But also, being on a call with them at this critical time was reassuring in case anything went wrong. The gist of the migration itself was pretty simple. Like in our earlier tests, Microsoft first created a follower hyperscale instance. Then we disabled our writers. At this stage, the data in Citus Cloud was essentially frozen. So our queue would simply accumulate messages for now. Then we did one last manual write in Citus Cloud, and we created a small empty table which acted like a sentinel. We then waited for it to appear in hyperscale. At this stage, we knew that both databases were completely synchronized. So then, the Citus team promoted the hyperscale instance to be standalone. Then, we simply switched our reads to the new instance, as we had done before in our read testing. We monitored for a few minutes. Then, we plugged our writers again, also pointing at the new hyperscale instance. Again, we monitored for a few minutes, and voila, everything went according to plan. All in all, including some small hiccups along the way, the whole process took 40 minutes. The following day, we ran the same migration on our US cluster, which went exactly the same way. As a recap, here is the overall timeline. The project started mid-October. After our first initial assessment and our first conversations with Microsoft, the first database setup was done on October 25th. It's during the following week that we did most of our testing and that we discovered the right issues that Antoine described earlier. A week later was our test in prod. As everything went fine, the following day we migrated our European cluster and the day after, our US cluster. We kept our old instances for a few weeks, just in case, but after 3 weeks going smoothly, we simply decided to drop them. Our goal with this presentation was to share a few of our key learnings of this journey. But if you had only 2 slides to remember of this full presentation, we'd encourage you to focus on the next one. Overall, we can split our takeaways in 2 big categories. On the must-haves, we cannot stress enough the importance for this operation of our monitoring, of the exhaustive migration playbook that we wrote, and of restraining our biases. But there are also a few other takeaways that we'd like to talk a little bit about. First, if your system doesn't require real time, consider using eventual consistency instead. Being able to queue messages while we affected the main data store is actually the main reason we managed to have a zero downtime migration. Second, the idempotence of writes was a great ally for us to investigate performance issues. Instead of having to recreate a testing environment that mimicked our production, here we could simply replay the same write queries in different scenarios over time. Third, be prepared for the unexpected. Even by planning as much as we did, we still got a few hiccups on migration day. To be more specific, we got some merging issues on GitHub with some stacked pull requests. However, we knew we could focus on this issue and then simply come back to our migration playbook after. And our final takeaway, and it's actually the main reason we're presenting this as a duo today, is we did this migration together and we validated almost everything with each other along the way. And it was a great way for us to challenge ideas, to ensure that we didn't make any manual mistake, and overall feel way more confident during the whole process. So if you do have to tackle such an operational project in the future, we can only recommend you to find someone else to do it with. Before closing this presentation, we wanted to take this opportunity to thank, first, the Citus team, especially Sumed, both for being responsive to our questions, but also for having managed a main migration. Second, Microsoft, of course, for inviting us to this conference. And finally, you for listening to this presentation.
But we have one more thing to share with you. Algolia is hiring, so if you want to work with the amazing Matthieu or I or all the other amazing people we have at Algolia, feel free to go to algolia.com/careers and apply. We have more than 100 open positions in the product dev organization. So we'll be happy to answer any question live, but other way you can find us both on the Microsoft open source Discord, or you can reach out to us via email. Thank you.
Thank you.
That was lovely. Thank you.
Thank you.
you.
Yeah, I got to see a dry run of your talk, so I had a little bit of an inkling of the story and the journey that you were going to tell. And, you know, one of the ways that all of us learn is by seeing how have other people solved this problem? How has somebody else managed this migration? So I think probably a lot of people, not just on this live stream, but, you know, on the published video later are going to benefit. So thank you for telling your story.
Thank you so much.
Thank you.
Actually, it was the main source of inspiration for us. When we began this migration, we went looking online for resources on how to
do
it, and we couldn't find anything that convinced us and was deep enough, so we wanted to share a bit.
Yeah, that's why we did this talk, and we also wrote a blog post about it, so people can benefit from our work.
So actually the blog post the talk that I gave, sorry, my words are munging together in the middle of the night, was about ways to contribute to Postgres beyond code, and giving a talk and writing about your experiences were absolutely on the list of ways to contribute. So thank you. I do have some questions here. So one of the ones is whether there are parts of this talk that you think would also apply to like a standard Postgres instance?
Overall, in general, most of this talk applies. Citus is a distributed Postgres, but what was done by the Citus team by creating a follower can also be done on a standard Citus instance, standard Postgres instance, sorry. The great part for us was that it was a Citus team handling this for us and creating this follower, promoting it to be standalone, but it could be achieved by anyone on a standard Postgres instance the same way. The other learnings we had definitely apply in general to any Postgres instance and aren't Citus specific.
Okay, cool. And there's another question on the Discord asking you to expand a bit on the idempotence bit that you mentioned at the end of your talk.
Yeah, sure. So the whole analytics pipeline of Algolia was designed to be idempotent, and that's mostly because we can leverage some specificity of it. So because the analytics data are historical and immutable coming from our log, we can take a unique identifier for each entry, which allow us to deduplicate the logs. So as long as we don't change the function processing this immutable data, the output of this function will be the same. And that's very useful for multiple reasons when you have production incident or a migration.
Awesome.
Partially.
Well, thank you both very much for joining us today. I hope you hop on over to the Discord to answer questions
We
or
will, for sure.
We will
maybe
for sure.
offer an office hours or something like that, and maybe come back every day this week. We'll see how questions roll in. Thank you.
Will do. Thank you so
Thank you-
much.
Thank you so much.
Have a great day.
Awesome.
Bye-bye.
All right. Now I'm waving goodbye to Matthieu and Antoine, but I'm not waving goodbye to everybody who's watching on the live stream. We have more talks. We are not done yet. So the next talk is by two co-presenters named, and I'm going to botch one of their names, Alicja Kucharczyk. And I work with Alicja, and I've never had to pronounce your last name, not once. Is Kucharczyk correct?
Not
No.
really. It's more closer to Kucharczyk.
Oh my goodness. I'm so wrong.
At Polish, it's not an easy language, yes.
Okay. All right. So can you pronounce my last name?
Giordano?
Oh, that was perfect.
Thank you.
Okay. And you have a co-presenter as well. So Diaa should be joining us, and it's Diaa Radwan.
Yeah, this is perfect. Yeah, thank you.
Okay. All right. So 1 out of 2. So both of you work for Microsoft, and Alicja, the entire time I've known you, you've worked in the field, based in Europe as a global black belt, which I think means you work with a lot of big customers, helping them with complex Postgres implementations. Is that a good description?
Absolutely, yes.
Okay. And then Diaa, you're also in the same global black belt team, and it
Exactly.
looks like you've also been focused on open source databases as well in your time at
Yep.
Microsoft. Cool.
Yep.
And you're here today to talk to us about Oracle to Postgres assessments, which is a super popular topic. So with that, I think I will step backstage and let the two of you take it away.
Thank you.
Yeah, hello everyone. Thank you for attending our talk today. We're excited and happy to be part of CitusCon. As we mentioned, I'm working for Microsoft. I'm based in Luxembourg, focusing on open source databases, and I help customers across EMEA to adopt open source, migrate from proprietary databases to specifically Oracle to open source and Postgres.
Yeah, hi everyone. My name is Alicja Kucharczyk. I'm based in Warsaw, Poland, and I used to work together with Diaa at the same team, but recently moved to the product group. So I'm currently program manager at the Azure Database for Postgres team.
So as we work with the customers every day, they ask us about how we can migrate to Postgres and what is the challenge that we would go through, and how we can start on the migration projects, and what is the tools that we can use. So we see that every day as our job, and in my previous jobs as well. So one of the challenges is the tools. Once the teams decided to move, or they're having compelling event to migrate, so they start to say, okay, how we can assess existing databases that we have. And most of the time, they lean to open source solutions to assess their databases. So we have a lot of work with Oro2PG. Oro2PG is awesome. It has been there for a long time, and a lot of the we see a lot of challenges with the customers when they are using Oro2PG. So we put things together in one package called OSSom. So it is the OSS Open Migrator to help customers assess their databases using Oro2PG, but in easier way. So with the agenda today, we start with the what's R2PG that we're talking about. This is the core part of our project, and also the challenge that our customers see with R2PG, and how OSSom made it easy for assessments and our customers to use it. And also we'll talk about the architecture, small demo, and we'll tell you about the roadmap, asking you about feedback as well. What you wanted to see and how you can contribute to it, and when it will be open sourced, and then closing, and hopefully that we'll have some questions from you, and then we'll be available on the Discord channel to get your questions.
Okay, so let me tell you a few words about R2PG. So that's the tool I'm using to migrate our customers. So for the past 2 years, I migrated like a lot of them using exactly this tool. And I love it. I absolutely love it. The tool is developed for over 20 years now. It's got a lot of features. It can generate the assessment report, so you can assess how much time your migration will take. It also has scripts that you can use to automatically export your Oracle schema to Postgres in one shot. So there is one script for that. And then you've got another script that allows you to migrate the migrated schema directly to Postgres. It does both. So it's migrating the schema, so the DDL from your Oracle database, and also if you do not have need for the online migration, you can use it for data migration. For the very simple Oracle schemas, what we see is 100% of automation, which means you don't need to do any manual work in order to have your database migrated from Oracle to Postgres. For a bit more complex schemas, you need to do some coding yourself, like in order to work on Postgres. Yeah, it's not only me, but thousands of people around the world like using the tool successfully, and there's been a lot of databases migrated using this wonderful tool. But let's go to the next slide. What's wrong with R2PG? Myself, when I had my first migration, I needed some time to get familiar with the tool. It's not like you are just launching it and you know each feature that this tool has, and you are able to do each stuff that your customers want you to do. Like, it took me a couple months to get familiar, to get fluent with the tool. And I believe it's the same with other people. Our customers do struggle very often, like first with the installation, which is not the easiest one that you might see. It's got a lot of dependency. You need to download many packages, external packages, in order to work, export the paths, and it's really not straightforward process. Other thing that we saw, it's you need to be familiar with command line tools, and it's also not each customer of ours like it's super familiar with command line tools. It's also, as I said before, R2PG does this ability to generate HTML report with the effort assessment. But this report is super detailed, which from one hand, it's very good, right? Because you've got really detailed report, what needs to be changed, which function, which particular function would require more work. But on the other hand, you really need to have some knowledge about Postgres to interpret that correctly. Probably the report, it's not something you would like to have in your deck to present to the upper management. You need to put some work in order to make it more readable for them. And the estimation, which is our last point, the estimation are done by the static code analysis, which is one way of doing that. Diaa will show you the way that we are doing that in the OSSom.
Yeah, so we saw all of the I wouldn't say issues, but the blockers for our customers and the community to use the Oro2PG, and we made that based on Oro2PG. So we're building on top of the experience that Oro2PG has, and also we look at the command line tools and everything around it, from installation and so on. So we built that in a guided deployment with containers, and you can start in minutes doing the assessment for the complex databases, and also the OSSom interface that we have. Alicja will show that in this talk, that you can start using it with the very simple steps to connect to the database, get the assessment report, and also deploy it anywhere. So you can deploy it in your desktop, on dev environment, or production environment. It will be in all containers, and it is easier also to work with the schemas that you can export. And there is additional things that we would avail for you for the assessment report. So the assessment report is not it's not just the converted schema that you have to work with, but what you can do is to see the outcome of the Postgres converted schema. So in the background, we take the schema and apply that to Postgres and see exactly how many errors and how many successes there, and we give you the actual results. So it's kind of give you the view of what's going on with the migration. And we work with a lot of customers. Some of these customers have 5 databases or thousands of databases. So we know and understand exactly the problems of the multiple deployments. So having that all containerized, so you can deploy it in Kubernetes or any other platform that you would like. So it allows you to connect different environments based on the challenges that you have. So OSSom as a packaging is open source. It is published will be published under the MIT license. It will be shipped with the Docker Compose or Pullman Compose definitions, and also Kubernetes manifest will be available. And the Flask is the web UI that we're using. So it is connecting with the Oracle database, and I'll show you how it is connected now. And the whole environment is containerized, and you can build the containers by yourself if you wanted to do that, or you can use the containers that we have. So this is the OSSom environment. So you have a Flask in the middle. This is the web UI, and you define the connection strings and apply the assessment reports and so on. And the connections will connect to either the Oracle demo that we have or external databases for Oracle. And then it will take the read the information of Oracle, apply that to Postgres, and first, it will go to Oro2PG to do the conversion. It will connect over HTTP. There is, and then it get the converted schema, apply that to Postgres, creating the report for you, and then you can run that a couple of times. You can apply the schema a couple of times and run that again on Postgres, and then you can see the outcome and the results. So with this, I'm going to share my screen to show you a small what you will go through if you want to deploy it. So this is the environment. Hopefully you're seeing my screen. Yeah. So now you can see this is the Docker Compose file. It's easy one to go through. And what we will do now is bring the Docker Compose up. I'll prepare the environment for Alicja, so Alicja can do the login. I built that before, so starting the Oracle environment for the demo, the Postgres database that we will be using to apply the converted schema, and also we'll have the ORA2PG, which we'll be using for the actual migration and schema conversion. So Alicia, the environment is up and running. Show us the web interface. Thank you.
Yeah, thank you. Do you see my browser already?
Yeah, I see the cube puppy that we have.
Thank you. Okay, so that's the main screen of OSSom. And then we try to simplify our software that much as possible. So basically, you've got one pane, like to add your connection to Oracle. So simply, you need to have like some connection name, then the IP of the host that your Oracle is working on, then obviously the port, SID, the username, and the password. You will see like the list of your connections up here. And then what we created, I already added my Oracle connection, so I don't need it to do that anymore. So then you're going to the migration wizard. And what you're doing up here, it's choosing your database connection, then clicking next. You see all the schemas that you've got in your database. So let me choose the simple one that you probably all are familiar with already. So what is happening right now, it's ORA2PG, it's starting the actual migration. So we in the background, we migrating the code from Oracle to Postgres. And then like the migrated code is then deployed to the Postgres instance that we also have in OSSom. And then like the last phase of the whole thing, it's the counting the objects that were successfully migrated and counting the errors. So then we are able like to show you the percentage. So how many, for instance, tables were migrated successfully and how many were not. And then you see the list of all the object that you had in the schema. So for instance, in the HR schema, we've got 7 tables. All of them were successfully migrated to Postgres. There's been one view, so it was also successfully migrated. 2 procedures that were also migrated, and the triggers, like 1 trigger that was also migrated. So the success count is 100%, obviously. But this is like super simple HR schema that you probably all know. So it's super simple. Obviously, with more complicated one, you will see also up here like the error count, and the percentage will be calculated accordingly. And you've got like some information about the source system also, and the migration effort that you see up here, it's the migration effort that ORA2PG has calculated. So it's basically for testing because like 100% were migrated successfully. So the thing that remains, like it's only the testing. So connecting your app and doing the testing. Okay, so back to our roadmap. If you can put it up, thank you. Okay, so as you see, like our software is now like more in the puppy stage. So in order to make from the puppy like really a mature dog, like German Shepherd kind of dog, we've got like some points also to add to our software. So with super simple schemas, as you saw before, like HR schema, we don't actually need much more. But obviously, most of your Oracle databases are much more complicated. So you need to do some intervention. So you need some manual coding to be done. So for that, we're planning to integrate the migrated code with GitHub or any other Git that you might have, so you are able like to do your changes and then also like test the migration, like compare the schema, etc. And then obviously we'll need the schema comparison. So you will be able like to see like how many tables were successfully migrated, how many procedures were successfully migrated. You will have that in the one simple screen. And actually, this is the part that we are very close to finish. And also the data validation part. So if for sure like we have migrated all the data. And because what I told you before, like we're doing assessment by a real migration. So we actually already have at this point like the whole schema that you can use with Postgres. So we want also to add like next to the Oracle connections, also the Postgres connections. So the user can define like the connection string to Postgres database, and then just also by one click, just migrate the schema straight away. Then the online data migration, which will be a bit bigger piece. Obviously, performance optimization, because for a couple of years of migrations, we have like a bunch of the scripts that we apply on the output of Ora2PG to make Postgres a bit more efficient. And so this is something that also we want to add to OSSom. Obviously, open sourcing OSSom, that is also the huge point. And then multiple schema and databases support. So for now, as you saw, like you need to add your database connection manually. So we want you to be able like to just upload, like for instance, CSV file with all the connections. So OSSom can do that like in one step. So over to you, Diaa.
So yeah, thank you for tuning in, and also for if there is any questions that we can take, please use this form for the feedback on the tool and what you expect, what you want to see, and also if you're migrating from Oracle to Postgres, we're happy to discuss that with you. It's not necessary that you migrate that to Azure platform, but we're happy that you take Oracle out. Yeah.
Awesome. Thank you. That was lovely. I have a bunch of questions for you. Are you ready to stay on for a couple minutes and
Yes, sure.
Try to field some of these? Okay, let's see. So what was the biggest migration story you did and how did it go? And what are the non-technical challenges? That feels like a half hour or an hour long discussion, doesn't it?
Yes. So I did so many of them, so it's really hard to say which one was the most complex one. I believe like the biggest one, I might say like it was the database where I had like 50 packages to migrate, and in each package, like in average, it was like 200 of different functions and procedures. Yes, that was a big thing.
Oh my goodness. Okay.
Yes.
All right. Are there typical differences that people notice once their applications have been migrated from Oracle to Postgres?
Typical differences, yes. Obviously, like the Boolean, probably. That's I believe that's the first. That's the first pain point. So there's kind of attitude because on Oracle you don't have Boolean data types, right? So once you migrate to Postgres and Postgres has got like the native Boolean data type, then it takes like some time to convince the Oracle people that were using like for instance number, character or whatever for a very long time, that they probably want to switch to the native data type. So this is probably not that it seems to be very simple one, but it takes sometimes really a lot of time. The same with JSON. Like what is sometimes funny, like people put like JSON like in the CLOP, and then in the comments they've got it's JSON, right? So you also need to convince those people like probably like, JSON-B might be a good idea to use. So yeah.
Well,
Got
one
it.
thing, Claire, that you mentioned within the question is the non-technical issues. So when you have a migration of 5 databases, is different than thousands and hundreds of databases that you might have within the environment. So we work with customers on both sides, and the technical issues sometimes is easier because you have to fix things around the process, training, skills, and also getting out of the licensing. It takes a lot of non-technical discussions. Normally, we don't have these discussions with the customers, but most of the time, we guide the customers how they can do it in a structured approach, and we give them how they can successfully migrate and make cost savings. It's not about cost only; it's cost and also flexibility that they would have once they move to open source database, and something like Postgres, especially if it is a managed service, will be easier for them to manage and optimize, and also have flexibility in their environment.
What are typical downtimes during migrations so far? Is there a range?
We always like
It
encourage
depends.
people.
So,
Yes, sorry, go ahead.
it depends. This is my answer, but Alicia, go ahead.
Yeah, we always like trying like to convince the customer that's probably the best way is doing the offline migration. So just take the downtime and like, because this is like way easier to set up. But if the customer really needs to do the online migration, then we've got a set of tools that we can use. So, and it depends on the tool that you are using, to be honest, and of the overall setup, the database workload, many factors. So it's hard to give you like the concrete like number.
Okay. All right. Last question. How do you migrate the queries in your application? Are there any tools that can help?
So there are like multiple tools that you can use, but most of them are paid. So they've got some like license, right? What I'm usually doing, I'm just running the app against my migrated database. Then I'm like gathering all the logs from Postgres database, and what I'm doing, Ora2PG, what I said before, Ora2PG, it's not, it's got a lot of options, but you need some time to get familiar. So there is also this option in Ora2PG that you can give Ora2PG a text file with your queries, and then Ora2PG will convert your queries also. So you've got like with running the app against your Postgres, you will have like all the queries that you need like in the log, and then you are taking that and putting like as an input for Ora2PG, and then you've got as an output like migrated queries.
Awesome. Well, I think we're out of time. We're going to cut over to the next speaker. I want to thank the two of you for putting together your talk, for putting together this new capability, and all the work you're doing with customers to help them in this transition. So thanks for joining us. Appreciate it.
Thank you for having us.
And hop on over to the Discord if you can.
Obviously, yes.
All right. Okay. Thank you. Right. So next up, we have, let's see, I'm heading over here to the schedule. I want to introduce Johannes Schuetzner. Did I say your name right, Johannes?
Yeah, that was perfect.
Okay. So Johannes works at Mercedes-Benz Research and Development, and you actually work on the Mercedes-Benz operating system. Is that right?
Yeah, that's right. That's kind of the big topic we're working on. Yeah.
Got it. Well, maybe you also work on other things that you can't talk about. But the thing that you're here today to talk about and to share with us are your first experiences with Azure Database for Postgres, specifically the new flexible server deployment option. So I'm really interested to hear what you have to say and what your story is. And I'm sure everybody else is as well. So you can take it from here. Thank you.
Yeah, thank you, Claire. I'm glad to be here. It is my honor to be part of this event. As I said, I'm part of Mercedes-Benz R&D in Sindelfingen, Germany, and we develop software running in the cloud. So it's really a group of people developing software for the cloud, and we rely on Postgres as database server. So we were quite interested when we learned about the new Azure database Postgres flexible server that was introduced last year. So there are a number of capabilities and features available that appeal to us. So my goal for this session today is to share our experiences and lessons learned. So it's kind of based on different discussions we had with other teams internally and also externally. And it should hopefully then make your journey to flexible server a little easier if you plan to go there. A little bit on my background. I've been in software development for a number of years related to database processing. I was working in the enterprise application space and also have worked closely with banks in like South Africa and Australia for some reason. Okay, so what are we gonna cover today? First, I would like to set the context of what we are doing. So it's MBOS, Mercedes-Benz operating system. So I'd like to talk about this briefly and then show what we are developing specifically. After that, I will introduce the new Postgres flexible server offering, show its capabilities, and also highlight some of the differences to the kind of traditional Postgres single server in Azure. And then the main part will be sharing our experiences and lessons learned. And I intend to follow more or less kind of a typical kind of workflow. Like first we like to provision the flexible server, then take care of network security, some operational aspects, and then finally talk about the new burstable compute here and zone redundant HA. Okay, so Mercedes-Benz operating system. So what's that? And basically, it's a standardized software platform that's the foundation for the next generation of Mercedes-Benz vehicles. So it's really the relationship between the cloud infrastructure software in the car, Internet of Things devices, so everything that's kind of the base software that is then needed to make these future vehicles run and operate. There are 4 vehicle domains in MBOS: automated driving, infotainment, driving and charging, body and comfort. And it is developed both in-house and with partners. So there are multiple locations, like in Sindelfingen, where we are located, but there are also other Mercedes-Benz locations around the world. The building that is highlighted in the middle of the slide is the new electric software hub, and just by chance, it was officially opened last week on Friday. So that's kind of one of the center pillars of these activities. And if you think that's kind of an interesting topic, and this is really something for you, we're currently hiring. So if you're interested, then you may have a look at our website and check the job postings. So in this context of MBOS, I mean, there are different use cases. Many focus just on single vehicles, but then there are also other use cases where a set of vehicles needs to be treated. So for example, you need to roll out software to this set of vehicles, or you would like to enable feature toggles for a specific set of vehicles. And that's why fleet management is an important topic there. And it also allows then other applications to really use predefined fleets so that these different tasks all operate on the same sets of vehicles. So that's why kind of fleet management is one of the underlying components of the overall infrastructure. And we developed this solution. It is based on like multiple microservices. It's a cloud native approach. It requires to encrypt the data with kind of Mercedes-Benz owned key, so for data security, data privacy reasons. Typically, each microservice has a dedicated database to store its data. But we don't only have like single instances per microservice, but also like we have typical like dev, non-prod, prod environments. Then we have multiple regions across the globe for the different markets and different customer bases. So that's why really we have a number of databases, and so to keep these databases operational and manageable, and to be able to exploit them as good as possible is important to us. Since Mercedes-Benz is committed to open source, using Postgres for the database server is kind of a natural fit. And so we've used the Azure Postgres single server for a number of years, and this has worked fine. There were some observations that we made over time. So, I mean, we were still on Postgres version 10, so it's kind of a little outdated in the meantime. Then we encountered from time to time some issues with the SMB file handles to access the data on disk. So there were some issues there. And then, of course, the workload varies, and also depending on the state and on prod. I mean, the workload is typically way bigger than on the dev environment, where some developers develop software and run some tests, but nothing much going on otherwise. And so it would be good if the costs are then only kind of incurred when there's really big workload. I mean, that makes sense. But on the other hand, if there's no workload, like in a dev environment during the night or very little, then it would be good if we can reduce the costs. A good thing about Postgres single server is that as a managed service, it takes care of applying maintenance under the cover. If there's a new like operating system patch that's required, or some new Postgres minor version or patch, then this is all applied automatically. But it's not possible to decide when this will gonna happen. There's some information like from Azure and Microsoft in advance, like 3 days, I think, but then it's a 15-hour window, and so it may be at a convenient time or at an inconvenient time. Yeah. And then the last bullet here is kind of, as the name suggests, it's a single server. So in case of an error, it needs to be restarted, and so there's no failover solution because it's really a single server. And I think having a failover solution provides some enhancements. Okay, and then that's kind of based on our own architecture. So we set it up such that every database resides in a dedicated Postgres server. I mean, this works fine. This kind of full separation, but there's some overhead probably, and so we have a potential here for server consolidation. So that's why we looked at how can we improve things based on Postgres flexible server, and it was introduced end of last year. So the Postgres flexible server in November of 2021. As you can see on the right-hand side, it's one of the options available for Postgres on Azure. That's also something that Magnus showed in his keynote earlier today. So I mean, there's single server still available, then there's flexible server, and the Citus offerings, but it's one new option that is available. And one big difference is already it's running on Linux. So Postgres single server is based on Windows, and flexible server runs on Linux like natively. I think that's an advantage, and it is more up to date regarding major Postgres versions. So it supports currently versions 11, 12, 13, 14 not yet, but probably this will also be available soon. And with Postgres single server, it was only version 10 and 11 that's supported. So I mean that shows really Azure is probably more committed to keeping this up to date and to remain current. And I think that's good, because with every new Postgres version, there are enhancements and new capabilities. So it's good to be able to take advantage of them. So there are a number of enhancements there. I picked 6 of them here. Sorry, just 5. Just 5, and would like to highlight them. So there are some cost optimization options available that are improved compared to single server. There's a new burstable pricing tier. So I will talk about this in more detail later. Also, it's possible just to stop the server, like for dev systems where there's no workload at all during the night. That's a benefit. Then it is able to scale across pricing tiers. So again, looking at dev environments, maybe you will start small, you will just, I don't know, play around with, and then you can use like a simple basic pricing tier, and later you would like to scale, and this is not possible with single server. You have to unload and reload the data, and with flexible server you can just scale across these tiers. A really big enhancement, in my point of view, is the zone redundant high availability with synchronous standby. We have two Postgres server, and they are transactionally consistent. And in case one of them goes down, then it is possible to fail over without losing data. Then the PG bouncer connection pooler is available. That's an option. You don't have to use it, but you can use it directly on the server side. And then finally, you can schedule your maintenance windows. I mean, the maintenance windows that Azure uses to apply for your Postgres instances. Okay, so let's have a look at our hands-on experiences. I mean, they're really kind of, I don't know, hands-on, some basic observations, but I think it can help just being aware of them, so that kind of, I don't know, you know what to expect and how to deal with these changes. And I think these changes, some of them are also documented in the documentation, of course, but for me at least, it was such that, I mean, I've read about that, but then when I saw it, it was a more kind of, I don't know, more immersive experience. So in our case, we use Terraform for the deployments of the Azure infrastructure. And so we had to update our Azure provider so to have a version that supports Postgres flexible server. So we are on 2.91.0 now, so that works fine. And one limitation so far is that customer managed encryption keys are not supported yet. So bring your own key. So that's not yet available, but I heard that will be coming, so it's a matter of time. But that meant for us, so that for now we provision the flexible server only to our dev environments, where we have really just generated data, test data, no real data, so there it doesn't matter. And so we plan then to go to Flex server on other stages later. The goal of our setup was then to be able to provision these different types of flexible server in a single pipeline, so that we can just specify, okay, for example, in dev, we would like to have burstable Postgres flexible server for non-prod prod, currently single server, in the future flexible server with zone redundant HA. So we need to be able to, just by, I don't know, making a check mark somewhere, changing a flag, saying, okay, I would like to have burstable here and flexible server zone redundant HA in the other environment, for example. Okay. So what we did was then to define a resource in Terraform here for the new Postgres flexible server, and then for this SKU name attribute, we have a variable where we can say, okay, that's burstable pricing tier or general purpose pricing tier or something else. And then there's a new parameter for the high availability configuration. So I mean, this looks straightforward, but the downside is that it doesn't work, because the high availability attribute is only available for general purpose or memory optimized pricing tier, but not for burstable tier. So it's not supported there. And so what we did was to introduce further variables and a Terraform dynamic block in the resource definition. So as you can see, we have, like, for dev, we have a variable high availability equals null. We don't need it there. The SKU is B standard, so B stands for burstable. And then for non-prod, we say, okay, SKU is GP, general purpose. And for the high availability config, we use a variable. And I show you this variable on the upper left, on the upper right of the slide. So it just has two values, the node, so zone redundant, and the standby availability zone. And then on the left-hand side, you see this dynamic block at the bottom, dynamic high availability. And what it does is that it reads this variable during kind of the deployment. And if it's kind of empty, then the whole block goes away. And if there are some values in this block, in this variable, then these values from the variable are then inserted into the block, and then the parameters are available. So that way, we are able to have a single resource definition and still can distinguish these different setups. Also, there's one attribute called zone, and that's also quite useful because there you can specify the Azure availability zone. And so you have control in which availability zone your flexible server will be provisioned. And if you have this co-located then to your application, like to your Kubernetes cluster being in the same availability zone, then you have a better latency because then application and database are in the same zone. Network security for the single server, there was an option to have multiple VNets that are associated for a flexible for Postgres single server. And that means all components within these VNets were allowed to access the database, but Flex server is more strict and also maybe more clear. There are only two options: private access and public access. And with private access, there's no public endpoint. So that means, like from Azure CI/CD pipelines, you cannot access the server directly. When you can have self-hosted agents, for example, then it works. But if you would like to have public DNS name and firewall support, then you would have to use the public access, which is what we did. And we automatically specify firewall rules as part of our deployments, and we use the IP ranges from the Kubernetes egress, so they are well defined, and so we can use these ranges and then insert them in firewall rules, and so that way we really have then a proper configuration for all our environments. Okay, so at that point in time, the flexible server is available, up and running. Then typically the next step would be to create databases. So this is what we did. Here you see our Azure CLI command that we used for a single server. When we specify Azure AZ Postgres DB create, then we specify a name, character set, collation for the order sequence. I mean, that's just standard. But then I was a little surprised because just converting this statement or command to the AZ Postgres flexible server didn't work. So we specified the same name, character set, collation, but what we got was an internal server error saying, okay, unexpected error occurred. Okay, and so I was a little unsure what's wrong with that. But then it turned out it's actually good because, I mean, remember, Postgres single server runs on Windows, and so we used a Windows-specific collation ID. So 1252, that's a Windows-specific code page. And actually, with flexible server, we are now on Linux, and basically we only want to have UTF-8 data. And so with Flex server, we are able to specify also UTF-8 for the collation ID, and so that's then a proper setup. So that's good. With the Flex server, you don't have the Postgres server logs in the Azure portal. I mean, for single server that was available. With flexible server, there are multiple options, like you can have the Azure logs being propagated to an event hub, to a storage account in Azure, or to the Azure log analytics. And this is what we enabled. And I think that it's really powerful because then you can analyze your Postgres logs using the Custo language in Azure Log Analytics. So I think that's good. And then little comment regarding the CLI commands. Here in that example, it's Azure CLI commands, but for PowerShell and other languages, it's similar. So the commands are kind of different. It's not rocket science. It's not that they are completely separate and new. It's just that they are somewhat different, and that means that if you migrate to Postgres Flex server, you would need to adapt your scripts to make sure that they are still running properly. Yeah, that's all just to be aware of. So some of the command options have different names. So more or less it's the same, very, very similar, but there are a few differences. Yeah, and also regarding monitoring, if you have like certain metrics that you use for monitoring dashboards or for your analysis in Azure, then there are different metrics. So in that case here, it's an example for Datadog, where it's a different metric name. It's just, I think, important not to forget about them, so that you still get proper metric values. Earlier, I mentioned kind of the cost savings that are possible with the Postgres Flex server. In our case, I mean, we did two things. We consolidated. I mean, we now have kind of a single Postgres Flex server per environment, and then we have the different databases within the single Flex server. So I mean, they're still properly separated because they are different databases, but it's a single Flex server. And we take advantage of the new burstable tier, and that's why for the dev stages we got a reduction of 86% for the Azure Postgres costs, which is really great, really great savings there, because I think there it's a really an excellent fit. So the workload is small usually, and we can consolidate perfectly, and we can take advantage of the burstable tier. So how does the burstable tier work? It is using these burstable VMs, and basically, if you have like if you have a pricing tier with one core, for example, then you are entitled to use 20% of that capacity at all times, and the maximum goes up to 100% per core, like 100% of one core for the first case. And the good thing is then, if you have longer periods where you have no or little workload, then you get credits for the CPU consumption that you didn't use. And so, for example, if during the night for 5 hours there's almost no workload, then per hour you get like 12 credits there for the first size that is shown here. And then during the day, when the workload is bigger, then you can consume these credits. So I think for these environments, that's really a good enhancement, and that helps reducing the Azure costs. Let's get to the last topic that I've prepared for this session today, which is a closer look at the zone redundant high availability. And it's, as you can see here, it is based on the availability zones. So you need to have 2 Azure availability zones, like 1 and 2 in that example. And your application connects to them as if it were a single Postgres instance. So there's a single domain name, and the application, like in the middle in this example, it always connects to this one logical instance. But internally, it's kind of primary server on the left and standby server on the right. So the service or the application always connects to the primary server, and all the data changes are then replicated synchronously to the standby. So that way the servers remain transactionally consistent. So that means no transaction gets lost if it has been committed, and even if there's a downtime. It enables the failover, so that's what I like. So the application just needs to reconnect and then ends up with a new server if needed. And let's distinguish 2 cases: planned failover and unplanned failover. So for the planned failover case, like typically Azure would schedule an update of some internal software like the Linux operating system, or would perform a minor version upgrade of Postgres, like going from 13.3 to 13.4, something like that. So I mean, this is planned. You can enable this via like Terraform, via scripting, or here also in the Azure portal. And I show this here because maybe it's better better to understand it or to show it. If you enable this here, you say, okay, enable high availability, then you see the high availability status. And so initially, that's not kind of healthy, it's kind of catching up mode, because initially all the data changes need to be replicated from primary to standby, so they have the same data. And then once they have the same data and the log replication has been enabled, then it's healthy. You have the primary server name, and that's always the same, doesn't change. And currently, the primary is in availability zone 1 and the standby in zone 2. Okay, you can also then control your maintenance window here. This is also what you can do here in these Azure portal sites. How would it then work? So if your plan failed over is started, the replication from primary to standby is suspended. Then as a first step on the standby server, the update can be applied, because then nobody is accessing the standby server anymore. Then all the changes that have been done on the primary server on the left-hand side, they are replicated to the standby. Then the connections from the service to the primary are drained on the left-hand side, so they're not allowed anymore. And then all the application needs to do is to reconnect, and then it automatically ends up with the new primary server on the right-hand side in the zone 2. So really from the application point of view, it's just doing a reconnect, and then all of a sudden it ends up on the second server, here, former standby. Now it has been promoted to new primary, and then on the left-hand side, that's kind of then the new standby, and there's no workload. So that's why the maintenance can be applied there as well. And so really the impact is that kind of small to the application, only here for the kind of this reconnection, there's a small kind of downtime. The other case is the unplanned failover, and this is what you would like to avoid, but I mean, you never know. Some underlying hardware component can fail, Postgres server itself can fail in theory. I mean, anything can fail. And so the official statement from Azure is then the expected RTO is less than 120 seconds. So, but this depends largely on the actual workload. But what is really good about this approach is then in Azure Portal, you can test this. So you can go to this panel again that I showed earlier and say, okay, now I would like to force the failover, so for testing purposes. And then this is failing over. You see the high availability status is now failing over. And at the bottom, you see the primary availability zone is now 2. So that means that really the switch is happening or has happened. So this is for the visualization of what I just explained. Initially, the data is replicated, then the primary fails, and the application reconnects and ends up on the secondary side. Okay, for our case, what have we seen for typical like downtimes or error rates? And this was in the range of 40 seconds. So as I mentioned, this depends largely on the actual workload, size of the workload, all these aspects. For us, it was like 40 seconds where we measured errors, which I think is good. It's good, but also don't get confused about maybe the messages in the operation log in Azure about the server, because you can see messages going way longer, but then this is more like background processing that can occur also after the failover. But then during these later phases, the application has already reconnected to the standby and is able to continue processing. Okay, so I think overall, the flexible server is a great offering. It's really a big step in the right direction. We like it, and I think we intend to roll it out further to more stages, also to other applications. What is currently needed is support for bring your own key, so that we can encrypt the data with our own key, and then also we would have to have it in China. Yeah, with that, thanks a lot. I'm happy to answer questions also later in Discord. But if there are questions now, we can also discuss them.
Hey, thank you so much. I really appreciate your talk. And I know that the entire team in engineering and product that's been working on flexible server is going to be excited to watch it as well. Half of them are asleep right now, but the good news is all these talks are being recorded and they'll be published on YouTube and docs.microsoft.com, so people will be able to access them later. I do have one question. I think we have time for just one question, and that is whether you have any observations about the performance of flexible server as compared to single server on the Azure managed service.
Yeah, we have some initial observations, but not completely kind of reproducible, because the issue currently is from our side. I mean, on the flexible server side, we can control the availability zone where it is running, but on the application side, we are not there yet. It's kind of random. So another team is working on that, so we can also control the availability zone of the Kubernetes cluster. And then once we have that, then I think we can have proper comparison, because currently it's like impacted by this mismatch potentially.
Got
But
it.
I mean, from what we've seen, it looks kind of promising, but I think it's not kind of a good foundation yet
Okay.
to claim final numbers.
Yeah, so you've got good engineering training. You obviously have to measure it and know definitively before you can answer this question. So I understand. Thank you again for coming and joining us at CitusCon, for preparing this talk and sharing it with everybody. And yeah, we'll be following up with you and making sure that you've got all the links, and join us over on Discord. Thank you.
Thank you, Claire.
All right. So for those of you who are watching at home or at work or at the beach on vacation, wherever you are, we have one more talk in the live stream. And then after that, we do have a post-show wrap-up session for about 25 minutes. So feel free to stay on. It could be fun. There will be highlight reels and more discussion about these talks. So a little bit of a backstage view. The last speaker is Marco Slot. Now, Marco, I've worked with for about 5 years now. He's the technical lead of the Citus open source database engine. And he lives in the Netherlands. And he has been working on Citus since long before I joined the team. I think you've been involved since, is it 2014?
Yeah, April 2014. So I guess exactly 8 years ago.
Okay. And then you did your PhD at Trinity College, and it says it's in self-driving cars, but I'm assuming it had something to do with distributed systems, because
Yeah,
what you do.
It was if you take multiple self-driving cars and you make them cooperate, like how do you do that safely and in a reliable and efficient manner?
Is that kind of what you've been doing ever since?
Well, I guess now I do it with databases. Yes.
Okay.
I'm always happy that my databases don't drive away, because that makes it very complicated.
All right. So the title of your talk, Citus 11, A Look at the Elicorn's Horn. Now, was that inspired by any other talk titles that you've seen?
Yes, definitely. Like, I mean, we had Magnus here earlier, and a talk that Magnus very often gives at various Postgres conferences is PostgreSQL, say 15, a look at the elephant's trunk. And of course, the elephant is the symbol for Postgres. At Citus, our mascot is the Elicorn, the elephant unicorn. So I thought I'd make a little tribute reference to Magnus's talks.
Okay, well, I hope he's watching, and I'm sure he'll appreciate it. With that, I will hand the baton over to you to talk to us about Citus 11. Thank you.
All right. Yeah, so for the final talk today, I wanted to take a little bit of a peek into the future and the latest Citus version that we're working on, which is going to be Citus 11. So before I do that, I want to talk a bit about Citus development. Basically Citus, as you probably know, is an extension to PostgreSQL that adds features to Postgres. I kind of like to call them superpowers. And it's really additive, so it doesn't change how Postgres works. Your Postgres server will just still work like Postgres, but it will be able to do other things as well. And in particular, you can distribute tables across other Postgres servers. You can replicate them using reference tables, and that's handy for doing efficient joins, distributed joins. And you can use columnar compression in more recent version. And when you query your distributed tables, the query will either be parallelized across all the cores and all the nodes in your cluster, or routed to a particular node, so you can have a very high transaction throughput. And so all development happens on GitHub, Citus data/Citus. And lately we're trending about 3 releases a year, 1 major release, 2 minor releases. Now, to be honest, there's not a huge difference between the major and the minor releases. The minor releases also have new features, but they're usually a bit more oriented towards performance and reliability and usability. And then the major releases have the bigger architectural changes that if you want to use them, maybe you have to test a bit more carefully, or they're just bigger shifts. For example, in Citus 10, we introduced this notion of starting on a single node, so you can just have your distributed tables on one Postgres server and then later scale out, and also columnar compression. And then in later releases, we kind of improved the performance and usability. 10.2, which is the latest stable release, also added functions for making it easier to do time partitioning of your Postgres tables and your distributed tables. And so Citus 11 is our next major release. So there's, as you might expect, there's some bigger architectural shift coming. And to explain that, let's first look at how Citus normally works. How would you normally use Citus? Now, typically in Citus, you have a coordinator and 0 or more worker nodes. And the coordinator is basically your initial Postgres server. Maybe it also has other tables, but it also can have now distributed tables. And those distributed tables have some metadata associated with them that's stored on the coordinator. The worker nodes, they mainly contain the shards, which contain subsets of the data. And so when you connect to the coordinator and you query a distributed table, the coordinator will make connections to the worker nodes to query the shards that have the actual data. And that way you can add as much capacity as you want and have, parallelize your queries over many cores, or keep a lot of data in memory, or have a lot of the IOPS bandwidth of many different disks combined. So that helps you scale your query execution for many different workloads. Now, it can be that you have a really high query throughput, and then having the one coordinator could eventually become problematic. But actually, a lot of the time, especially for large-scale applications, if you have a lot of data, what we typically see is that the bulk of the work is actually in query execution. So if your queries are starting to span larger amounts of data, and you need more horsepower to process that, in Citus you can just add more worker nodes because they're doing the actual query execution work. So then it doesn't matter so much that the queries are going through the coordinator. But if you're really doing very high throughput workloads, and particularly of queries that are maybe don't do so much execution work, like just single row lookups or single row inserts, then it can be handy if you can actually scale the coordinator. And to do that, the big feature introduced in Citus 11 is the ability to query via any node. So now the metadata and the schema of your distributed tables and your reference tables is automatically going to get replicated to all of the nodes in the cluster, so to all of the worker nodes. And you don't have to do anything to enable that. It will just work automatically. It also doesn't really have a downside. I mean, maybe strictly speaking, it adds a few milliseconds to some of your DDL commands, but they usually take a bit longer anyway. And then your application, if it wants to do a query, well, either you could still do everything via the coordinator as you normally would, or you could run your queries via any of the worker nodes. The only restriction right now is schema changes, DDL commands, new distributed tables. That still needs to happen on the coordinator. So the feature that enables querying from the worker node is this automatic schema and metadata syncing. It's actually under the covers. It's a pretty huge feature, but we try to do a lot of work to make sure you don't really notice it at all. So nothing changes about how you use Citus, how you set up your schema. So if you want to create a distributed table, you first create a regular Postgres table, and then you call create distributed table. This is how Citus always worked. create distributed table goes and creates the shards on the worker, but now it also replicates the table schema to all the workers. And it includes the sequences and constraints and indexes and any, like if your table has a default expression that calls a function that you defined, it replicates the function. So automagically everything will show up on the worker nodes, and whichever node you connect to will actually look exactly the same. This also makes some existing scenarios a bit easier. So in the past, if you created your own function and then used it in a distributed query, that query will get executed on the worker. So the filter, the where clause with the function call will get pushed down to the shards. But then if the function, in the past, like the function wouldn't exist yet on the worker, so you would get an error and you would have to do an extra step to create the function on the workers. That's no longer necessary. The function, every function you create automatically shows up on the worker, and same for other database objects like types and other things. So even if you're just using the coordinator, just to make your life a little bit easier. What then the net effect of that is that every node effectively looks the same. So whether you connect to a coordinator or any of the workers, you'll see the same set of distributed tables. You can query from them, you can insert into them. The only thing is that you can only do your DDL commands. Let's say you want to add a column, you still need to do that from the coordinator. Hopefully we can resolve this in the future, but currently you need the coordinator for that. The other thing to note here is that in the pictures I showed, the workers had shards. Those are regular Postgres tables, but when you connect to a worker, we don't show them to you anymore. And that's because we've had a lot of users kind of get a little bit confused by the shards. Like there are these tables that you didn't create that contain a lot of data, and we've seen users try to drop them or truncate them, and that's not a good idea. And it also confuses some applications. Even pgdump gets a little bit confused if there's shards in the list of tables. So we now quite aggressively hide the shards from different applications. And there's a setting that you can disable if you do want to see the actual shards that contain your data. Now, if you start querying your distributed tables from different nodes, it becomes a little bit trickier to know what's going on in your cluster. And therefore, we added several very nice views for giving you a global view. Of course, you still have pgstat activity, which shows you everything going on one node. So if you connect to a node and if you query pgstat activity, you see everything that runs in that node, but not what runs in other nodes. So for that, you can use Citus activity. So that is basically the concatenation of all the pgstat activities from all the nodes with some extra information like the node on which queries are running. And then there's Citus dist activity, which just shows you the queries being sent to the database by clients on all the different nodes. And here's an example of querying Citus dist activity, where you see queries that my application sent to the database. There's a very silly query here with a count and a pgsleep. So maybe I want to do something with that query, cancel it. And then a useful concept I can use is the global PID. So this is a new concept in Citus 11. And basically every connection that a client makes to a database server will have its own global PID. And then Citus, when it queries shards, which are also just regular Postgres tables, it makes additional internal connections to those other Postgres servers. And those connections will also have the same global PID. So it associates the thing that the client is doing on the distributed table with everything that Citus is doing internally. For example, I can take this global PID and look at Citus stat activity to see the internal queries that Citus is doing on the shards in parallel and see what those queries are doing. Are they stuck? Are they taking a long time? And what's neat is that I can also take this global PID and pass it into the pgcancel backend function if I wanted to stop this query. You can actually do this from any node. So you don't have to be connected to the node that is running that particular query. It works from any node because we did a very simple trick. The number at the start of the global PID is actually the node ID. So we can always tell from looking at the global PID, which node started this this query and has this which process has this global PID. So that makes it much easier to kind of administer and monitor your kind of large scale distributed Citus cluster. Now, a thing to take into account if you want to kind of get to higher concurrency and higher throughput, maybe by taking advantage of the worker nodes, but also in general, something to take into account is that your application may need to use more concurrent connections to get to a particular throughput. And that's kind of just a mathematical reality that even if your application is just whenever a query is done, it immediately sends the next query. The maximum throughput you can reach is the number of connections divided by the average response time. And so if you have 200 connections, which is maybe already quite a lot, and a 5 millisecond average response time, not that high. I mean, for some things it's kind of high, but for many things it's pretty fast, and especially in cloud environments, you have network latencies you need to factor in. But with 200 connections and 5 milliseconds response time, you can at most do 40,000 queries per second, no matter how much hardware you have, no matter how big you make your server, it'll never be higher than that. But your server can probably handle more connections. So if you go to 1,000 connections, for example, with the same 5 millisecond response time, you could get to 200,000 queries per second. So that's something to take into account, that to get to high throughputs, you actually need to also have, your application might need to do a little bit more. And one more thing that we have to factor in is that when the application connects to a Postgres server, that spawns a process. And that process will, if you query a distributed table, will make connections to the other nodes to query the shards. So every connection that the client makes to the overall database cluster eventually also results in a connection to every node. So we need to make sure that every node can handle a large number of connections. And we can do that by just setting max connections to a high number. And what's nice is that actually Andres, who gave a talk in the live stream yesterday, in Postgres 14, he made a lot of connection scalability improvements, where in the past, having a lot of connections in Postgres kind of had some performance downsides, but that's no longer really the case. But one thing that can happen is that maybe the client makes so many connections across all these database servers that Citus cannot make any more internal connections to query the shards. So to prevent that situation from happening, we added this setting, Citus max client connections, where you can restrict the number of connections that outside clients can make, such that there's always enough room for all the internal connections. And of course, once we introduce this into the managed service, we'll set this up for you. But if you're running Citus yourself, open source, and you want to scale to very high throughputs, this is something to be aware of. Another thing to be aware of is that sequences might behave a little bit differently in this distributed cluster. So if you're running your inserts via the coordinator, sequences behave just like in Postgres. They go 1, 2, 3, 4, 5. But now when we replicate the table schema to the worker nodes, if we just took the sequence as is, it would generate 1, 2, 3, 4, 5 on every worker node. And that means you get duplicates. And if you use the sequence in a column that has a primary key constraint, then you would get a lot of constraint failures. So to prevent that from happening, the worker nodes actually put their node ID in the first 16 bits of the sequence numbers that they generate. That way, you still get unique numbers from any node that you insert into, but you lose the property of sequences where they just kind of keep growing and growing and growing. So that's something to be aware of. And if you need the sequences to be monotonic, you should probably keep using the coordinator for all your inserts. Another thing to be aware of is that if you want to query via the worker nodes and you want that to scale, you probably need to load balance your connections across the different worker nodes. Unfortunately, several of the major PostgreSQL client libraries support load balancing. So for example, in Java, you typically use JDBC. And then if you specify the database URL, you can add a load balance hosts option and specify multiple host names. And then JDBC will kind of round robin across all the different host names, such that your application connects to all of the worker nodes. And PGSQL is the standard Postgres client for C#. It has this a similar option, slightly different syntax. Some alternatives are that you create like a DNS record where you put multiple IPs and use round robin. But one thing to be careful about is that when you make connections from the same machine, they might all end up going to the same IP because of DNS caching in your operating system. Another alternative is HA proxy, kind of typical TCP load balancer, or having your application just pick a worker node at random. So, of course, this is the goal of having queries go via worker nodes is ultimately that you could scale throughput. And so I did a little experiment on Azure using a 5-node cluster and a 10-node cluster, or actually I started with 5 nodes and then scaled out. And so the first on the bars on the left show the results with a single coordinator. Now I should say this is a 16-core coordinator, so it's not the biggest coordinator I could have picked. I could have easily picked a 64 coordinator, and I would have gotten higher numbers. The other thing is we actually recently did this experiment on some competing Postgres services, and the numbers we get here are actually higher than you get on the largest Postgres services on some competitors. So and because this inserts per second number is actually really high if you consider that this benchmark YCSB, when it does inserts, it does like 1 kilobyte, actually slightly more than 1 kilobyte insert. So these are really large inserts, like when you're inserting very large JSON objects into a database. And on the right, we see what happens if I query via the worker nodes. I can get easily 100, 200,000 of those very large inserts per second. So if you have that kind of a workload where you do a lot of single row inserts or a lot of lookups, this can be helpful. In general, for data loading, we do recommend to use the copy command, which is batch loads, for example, a CSV file, and that's often much more efficient than individual inserts. But sometimes that's just difficult to do from the application perspective. And so overall, querying from worker nodes is a very useful new feature that's coming up. And pros are that you get better scalability for inserts, for lookups, for CRUD operations. I didn't talk about it much, but sometimes we see analytical queries that merge a lot of data together on the coordinator. For example, they have CTEs, which return very large results, and then join them together. That can put some amount of pressure on the coordinator. And also, if you have a lot of reads from reference tables, every node in the cluster has a copy of the reference table. So if you read from it, it will also always be local. So that scales very nicely. But the downside is that you do need some separate URLs for schema changes and queries. So your schema changes should still go to the coordinator, but the rest of your application can use any node. You may, if you scale out, maybe you need to update those URLs. And also your sequences behave a little bit strangely. So with that, I want to switch to a short demo I recorded. So if we can switch to the video. Yeah, so here, this was actually using the cluster that I used for the benchmark, but on the left, you see me connected to the coordinator and on the right to the worker. So I create a distributed table via the coordinator, and I can see that it immediately shows up in the list in the worker on the right. So I'm connected to 2 completely different IPs, but it's actually almost going to be like I'm connected to only one Postgres server. So I have the same table schema. I can insert on one node, and then I can immediately always see that insert on another, on the other node on the right. Also, if I have things like unique constraints, they'll be correctly enforced. I can also, of course, update the row that I just inserted from one node and then query it from the other node. So it's a little bit like I'm just talking to a single Postgres server, even though I'm really connected to two different servers. The only difference is that if I try to do a DDL command, I can only do that via the coordinator, and the worker tells me to connect to the coordinator. So a bit about the monitoring. So let's say one of the worker nodes has a query that's taking a really long time, let's say an hour, and I want to kind of see such queries. So what I can do is query the Citus dist activity view for things that the client sent to the database. And I see, there's this PG sleep query, and I can see its global PID. I'm not connected to the node that's running the PG sleep query, but I can simply pass in the global PID to the PG cancel backend function, and it immediately gets canceled on the other node. So also operationally, it feels like I'm just talking to a single Postgres server when I'm using these views. All right. So finally, some like bad news, though I don't think it really affects anyone. So we deprecated a few features. This is something we would only do in a major release, but we are generally very much optimized for backwards compatibility. So we only do this if we really feel this is not going to affect many users. One feature we deprecated is append distributed tables. This was the original way of distributing tables in Citus very long time ago, where every time you load data, you create a new shard. It was a nice-ish model for append-only data, but it didn't work well with many like relational features such as co-located joins and foreign keys. And since then, Postgres has also added partitioning, which is actually much nicer for append-only data. So nowadays, we just recommend people use the default hash distribution optionally with time partitioning. We also deprecated distributed CStore FDW tables. So CStore FDW was our first attempt at adding columnar storage to Postgres, but it had some limitations. And recent versions of Citus have the columnar table access methods, which works much nicer than CStore FDW. So we recommend switching to that. Finally, we had a feature where shards are, or we still have a feature where shards are logically replicated. So this is separate from the replication we do within the managed service, where each disk is like 6-way replicated, and you can also have a hot standby. But Citus could also do some logical or some statement-based replication where inserts would go to 2 replicas, but then if they failed on one replica, we would invalidate that replica, and you'd have to do some expensive repair process. And that never really worked well. So we removed that part, and now you can still use shard replication, but only for scaling reads, if you really have a very high read throughput on particular shards, for example. So the good news is that everything I talked about, even though Citus 11 isn't out yet, we did actually already release the Citus 11 beta. So if you want to play with the new superpower, all the functionality is available. I wrote a blog post about it. You can find it at aka.ms/Citus11beta with the installation instructions, a link to the release note, and more information about all the features that are included. And with that, I want to hand it over to questions.
Awesome. Thank you. That was great. I loved it. I think everybody who uses Citus is going to appreciate this talk. I know you wrote a blog post already about the Citus 11 beta, but I feel like you dove even further. And then, of course, having a demo, that's always different, like being able to see it. I do have questions. I'm looking them up. You've just got to forgive me here. Okay, so you talked about the pros and cons of being able to query worker nodes. This question is about when you should use this new capability. Who's going to benefit in what situation for querying worker nodes?
Right. Yeah, I mean, the simplest way of using Citus remains just, do things via the coordinator. It's probably scales very far. But there are particular types of workloads, particularly these kind of very high throughput CRUD workloads. Actually, in Size Talk, in the first live stream, we also talked a little bit about that. it's kind of workloads where you traditionally use the NoSQL database. Those are a very good fit for querying via the worker nodes because the execution time is pretty small compared to the coordination time. So it puts relatively a lot of pressure on the coordinator. So for that, querying from any worker node is a good thing. We also do have some users doing analytical queries that do relatively a lot of processing on the coordinator. So then it can be useful, but in that case, I would recommend just start with the coordinator and know that you have this option later.
Okay. All right. And then I remember when I first joined Citus 5 years ago, there was already this thing called MX that was in beta. And so I know people out there who have read about it are probably wondering, like, well, is this thing that you're talking about MX? Is querying any worker node equal to MX?
Right. That's a good question. So I would say yes, it is, but the thing is, like, in the past, we already had some abilities to query via worker nodes, but it was kind of almost like a different mode with many more restrictions that you didn't normally have. So
Okay.
so we did have some users who used that different mode that we called MX, but it wasn't very mainstream. But now there's only one mode, which is you can always query from any node because we made everything kind of work seamlessly and synchronize your schema automatically to all the nodes. So MX is gone. It's now just Citus, and you can query from any node.
Okay. So what's next after Citus 11?
Yeah, good question. So I mean, in a way, our goal is always to make the experience of using a distributed table or reference table, like the experience of using the scalability feature, very transparent. So everything should just work like it does in Postgres. So there are still a few SQL limitations and a few DDL limitations that we'd like to address, and
Okay.
there's a long tail of things that are a bit harder to do in a distributed environment around foreign keys. So that's something we're always working towards. Better data management, like making it easier to scale out your cluster, is something we always are working on. I'd like to get to also just being able to do the DDL from any node, so you don't have to make this distinctions. So these are kind of some of the streams we're working on towards future releases.
Awesome. All right. I think we have time for one more question. From the Discord, is it possible to have a coordinator replicating things between an on-prem server and a cloud server?
That's a very interesting question. I always kind of think of it like with those kind of questions, my engineering brain always starts thinking about how I would set it up, and it's definitely possible. It's definitely hard and not something that works out of the box. Like there's different tools you could use. It could make sense to just use a more physical replication and archival, and one side pushes archives and the other pulls it. There's some other options. So it's definitely not something that Citus gives you out of the box, but anything is possible on Postgres.
Got it. Well, I really appreciate you being part of this. You were on the talk selection team, and you also generously contributed a proposal that everybody wanted to hear about. And I think that's because Citus is interesting in the way that it does create a distributed Postgres solution for people. So, but I'm biased. I've been working on this thing for a number of years now. And you're biased too.
Definitely.
Well, thank you very much. This concludes all 6 of our talks, but now you and I get to put on different hats, right? Me as the host and the co-chair, you as the previous host, and we have about 25 minutes to chit-chat or to look back on these talks. I'd love to hear your thoughts and feedback on what you've heard. And then I want to look forward to what are the other on-demand talks, or what do we want to make sure people know about in the Americas live stream or in the APAC live stream. So that's the agenda. Also, Juliet on our team will be popping up banners with useful links as we're talking. Like I know there's a survey link that I really want to make sure people see before they leave. Hopefully you won't leave. You should just stay because Marco's cat might come on by. My dog is asleep. It's the middle of the night in California. But there's the survey link. So you can fill out the survey multiple times, like just now on today's talks and then tomorrow on other talks you might watch. And of course, we want feedback on the whole event and whether you thought CitusCon was useful. The survey closes next Tuesday, April 19th at 11:59 p.m. anywhere on Earth time zone, whatever that means. It means like that way. It means east, west of me. Okay. Let's talk about today. Any thoughts? Any things you want to highlight about the talks from today? I'm going to pull up an executive summary of today's EMEA live stream. It'll take me a minute to find it, so don't wait because these thumbnails are very, very small. Aha, that looks like Magnus's face. Here we go. So here's today's lineup.
Yeah. I mean, definitely a great number of talks. So I mean, it's always great to hear Magnus speak. I'm also looking forward to the in-person Postgres conferences starting up again, especially PGConf EU. I went to it many times. It's a great event. But yeah, it's hard to disagree with with the premise. Like Postgres is definitely more relevant than ever. I mean, that's why we're also having this conference. Citus is also more relevant than ever, but you know, the Postgres ecosystem is becoming so big, and it's I wrote this extension at some point, which is much smaller than Citus. It's called PGCron, and it's just a thing for scheduling jobs in Postgres, like every minute or at 1 a.m. And then I keep a list of which managed service providers have PGCron installed, and I think there's already like 10 or 12 of them. And so there's all these different Postgres services, and there's a lot of different extensions. Like we've seen talks about PostGIS, but your typical Postgres server now already has like 20 different extensions pre-installed. So the ecosystem is becoming really huge. And then at the core, the Postgres project, it's just the rate at which it keeps moving is just phenomenal. Like every year there's it's like you get a merge command and you get a merge command. So it's like there's all these new features. Just I mean, essentially we all get for free as the Postgres users of the world, which is amazing. And of course, there's people like working really hard to make that happen. So people like Magnus, people like Andres and Melanie yesterday, and Bruce. And
Thomas last night while you were asleep.
Thomas last night, yes, I was asleep. I'm definitely going to rewatch that. So yeah, we owe a lot of gratitude to them for continuing to drive this project forward.
There were some choice quotes in Magnus's keynote today, like the one about how did it say something like nobody needs Postgres and yet everything runs on Postgres.
Right.
So
yeah, I mean, it's well, I don't know if like I guess at this point, if you run your application on Postgres, you definitely need it to keep running. But definitely, yeah, it was interesting, this historical perspective of there's always a lot of alternative databases. But yeah, the thing we also found out the hard way over the past 8 years working on Citus is that it's really hard to build a database. It's really hard. It takes really a lot of time. Postgres is so far ahead because it's so old. Like it has had so much development going in, but not just like development at random, development with inputs from the whole world, from the whole community, with actual practical problems and very good refined solutions to those problems that took many years or many decades to develop. And it just makes Postgres very, very good for a lot of different use cases. So and I mean, you could say, I'm not sure it's inevitable, but inevitably, like, you know, people like it as a database because it's really, really great technology.
Well, I think one of the things I liked about Andy Pavlo's keynote, now he is the professor from Carnegie Mellon University who, oh, I don't have it here. I'll pop it up though. He was the keynote speaker on the APAC live stream. So that's probably not this one. This would be, excuse me, he was America's. So give me one more try. I can't get it wrong this time, right? Because I've only got three tries. There you go. So when Andy was giving his talk, it was about self-driving Postgres. And so you talked about how old Postgres is, and Magnus talked about how it stayed true to its core, that focus on stability and robustness. And yet Postgres is evolving, as is open to change. And the notion or the idea of having a self-driving database someday, I mean, that could be a game changer.
Yeah, definitely. I mean, I guess the one thing the one downside of bad thing you could say about Postgres is it's not necessarily very easy to use, right? It's very versatile, so it has so many features, but you need to know how to use all of those features. And when you get into performance, especially, there's extended statistics, there's partial indexes, there's some partitioning, and you need to make a lot of choices around that, and it's not obvious how you make those choices. So like Postgres almost has this like enormous potential within it that if you can automate those decisions and give like all those performance benefits to anyone, I mean, that's huge. Because I mean, we've seen a few of the large Citus customer like Algolia today that we're not really talking about their performance, but they've gone through a lot of iteration to optimize their Postgres databases to handle a really challenging data problem on Postgres and Citus, and similar with some of the other Citus customers giving on-demand talks. And they went through all of these, you know, do we need like partial indexes and index-only scans and all these things. But if you could, right, if you could make that from like a long engineering exercise into something like the database just learns and does that automatically, that would definitely be game changing.
Well, and I think if we think about Sai's talk, so he was also in the Americas live stream earlier or yesterday for you, I guess. And he was talking about how to select your distribution column in Citus, right? How to select that sharding key, which is a really important decision that a lot of people make early on in defining their data model, right? When they're first adopting, if it's a native application, or when they're migrating to Citus. And it just, you know, makes you kind of think about, will that be automated someday, right? Can that intelligence that currently people end up thinking about, how will it change? Like, what's the world going to look like in 5 years, 10 years?
Yeah, that's an interesting question. One I think about often, but don't have a great answer to. I mean, there's different paths. Like there's yes. I mean, I see some distributed databases that just like distribute everything by primary key, and I mean it's relatively simple and automatic. But then once you start joining things together, it's like really slow because there's just no, like the relational part isn't there. It's not relating the different pieces of data that it's joining together by putting it on the same node. But then if you in Citus, we make it a very manual choice. You have to like distribute everything manually, so you have to make like a lot of good manual choices, and you can get to that performance, but it's much more difficult to some extent, depending on your application. For many applications, also obvious, but especially for complex application. So there's probably some middle ground there where it's much more automated, and then but to some extent, maybe the database itself also needs to become a little bit different. Like one thing is with distributed databases, it's useful if the query specifies like a filter on the distribution column, for example, because then the database immediately knows, the data's over there. But if that's not there, the application's not telling it that, then you know, can you magically solve that? Well, maybe that needs to be pulled a little bit more into the application. Maybe the application needs to have some layer in it that actually gives some hints to the database, for example, about what it actually wants to do. So it's not yet clear, is this something we can solve entirely in the database, or is it something that we need to kind of take a slightly more holistic view and include like parts of the application essentially in this automation process?
So I think anybody listening can tell that you've thought a lot about database architectures and implementations and the trade-offs, because there's trade-offs in everything, right? So
Yes.
I'm sure you talked about releasing 3 versions of Citus a year, 1 major, 2 minor, and each one of those is chock full of those design trade-offs. So before we cut to a video, because we've got a couple of roles that give little snippets of the on-demand talks that have already been produced, is there anything else that you want to highlight from the other live streams that just comes to mind? I mean, it's kind of not fair because we really want to talk about every single one of them, right? But we only have 14 minutes left. So
yeah, I must say I felt a bit embarrassed during Haki's talk that I didn't know most of the things that he was showing. I mean, I definitely knew the dollar quoting, but you know, there were some really neat tricks in there that I hadn't realized myself about how you could do the copy in PSQL, or the upsert trick where you ask the database how was this inserted or upserted. Those are some really cool tricks.
I think that Nils on your team commented on the Discord that not a day in his life goes by when he doesn't use the dollar quoting feature. It's just so handy. And it saves him time. And I'm sure that's something that Nils cares about, right? Nobody wants to be inefficient.
Yeah, it's especially handy for also functions where the argument of the function is sometimes a query, and it's so much easier. Like if you try to put a SQL query in quotes, then you have to like double quote, like escape the escaped quotes. It gets very nasty. So it's definitely a great thing to know about.
Yeah. Okay, so I think we should roll a video. And since your talk was about Citus and looking at the Elicorn's horn, let's roll the Citus video first.
With the single node Citus, we have partitions. We have sharded our partitions. And if you want to scale out those, let's say the sharded partitions, you can basically add nodes to your cluster. And after adding nodes, you can basically run the rebalance table shards commands to rebalance your sharded partitions on the, let's say, the multi-node Citus cluster.
I'm going to start by just talking about the basics, single row inserts versus copy, and for that matter, upserts, which are a wonderful Postgres pattern that should be used more often. I'm going to go from there into micro-batched and parallelized copy operations. And from there, we'll get into more difficult techniques. There's one I invented that I call index juggling that's worked out pretty well for me.
I'm going to break down each stage of our journey from 0 to 1 million events, from 1 to 100 million events, and then to billions of events. And for each stage, I'm distilling our learnings into lessons that you'll walk away with for you to use in your journey from choosing a database technology to scaling it up.
My name is Matt Dupree, and I'm going to be giving a talk on some lessons that we've learned from optimizing Citus queries at Heap. So quick disclaimer and a little bit about me. So I've been at Heap for a couple of years, and when I first started doing performance work, it was actually a little bit intimidating. People were using terms like pushdowns and shard sampling.
Not to meet you like virtually. I'm Ming Wei. I work in the Windows data engineering group. When I started off, I realized that Citus has a great distributed SQL query execution engine. Right, and from a few examples, as you can see, from the data engineer point of view, this is just normal SQL, right? So this is actually very powerful.
A big data researcher and developer at the MobilityDB team. MobilityDB is a spatio-temporal database system developed by a research team in the Free University of Brussels in Belgium. And this is my talk about how it integrates with Citus to support big spatio-temporal data that it changes over time.
Hello, everyone. Today I will be talking about following select statements through Citus internals. And in fact, what does it mean that what we will look into what happens under the hood when a user comes in and types a select query. And then we will while doing that, we will also have an opportunity to discuss some basic architectural diagrams of Citus.
Pretty
Awesome.
cool, huh?
Yes. I didn't see all of them yet, but I think I'm just going to watch all of them.
Yeah, I think you kind of have to. Min Wei's story is really interesting. So he works at Microsoft, but even before we were part of Microsoft, right? We were a separate company, a startup. He adopted Citus and Postgres together on Azure, and he runs this massive petabyte scale system. But the thing I find really interesting, because here we are at a conference, people are giving all these talks, and the way he discovered Citus is he was driving home from work. He'd been researching all sorts of different databases and technologies to solve his problem with scale. And as he was driving home, he just kind of put his phone on some conference. I think it was .scale in Paris from, let's see if I can get this, 2017. That was the year you gave this talk. And he just listened to it on YouTube. And it was your talk, and it was all about Citus and distributed Postgres. And that's why he started prototyping and experimenting and realized that, hey, this was going to solve his problems. Pretty darn cool.
Yeah, that's very cool. And yeah, I think also for him, it really comes down to, well, okay, Citus provides this handy layer of combining a bunch of servers, but then the number of performance features you have then in Postgres that you can just use with these distributed tables as well. That's really what made it work for him, because like basically his team collects the data from Windows devices, when there's a crash or just when you've got telemetry that's being sent to Microsoft for analyzing, for example, new Windows releases. Like if a new Windows release goes out, are there certain devices, like Microsoft cannot test on every device in the world, so it will do these controlled rollouts and see, oh, actually something went wrong on this particular type of device. Things got slower, it got more errors. So they collect all that data and they give, there's a lot of people looking at this dashboard, where, like engineers, product managers, and so that's a lot of queries per second, but it's a huge amount of data. And so by combining this distributed SQL with actually, indexes, partitioning, all of the Postgres performance features that you get, he was able to tackle this on almost like with a very small team and a relatively limited budget to some extent. I mean, it's a large cluster, but still, if you consider what it's doing, it's not that big in the end.
All right, so given the time we have left, I really want everybody here to see some of these other snippets of the other on-demand talks. I think the one we should roll next, I'm not going to say the name because the second I say the name, the video's turning on and I'll be cut off. But because Magnus was our keynote speaker, he works in the Postgres community, let's go ahead and roll the Postgres video.
I am the co-founder and CTO of OtterTune, which is a database tuning startup. Prior to this, I was a PhD student at Carnegie Mellon, and I graduated in February 2021. And during that time, I worked on knob tuning, and I also worked that entire time on Postgres as well.
I'm Francesco Tisiot, developer advocate at Ivan. And today, we together are going to understand how we can fix our strings. And, I wanted to give you an example of why we should fix strings, and I didn't have to go that far.
PsychoPG is the most used and advanced Postgres driver for Python. It implements the Python DB API 2.0, and it's distributed under the LGPL license. The library was released more than 20 years ago.
And I am here today to talk to you about a talk titled No Array of Sunshine, a data quality focused tour of data types. And what I want you to know is, and this is the big takeaway, is that this is a talk about how choices we make around data types can impact data quality.
I'm going to be talking about integer to big int conversions. It's an advanced data talk for Postgres. And I've got a bunch of material that we're going to have to cover in a relatively short time. So I do want to just jump right on into it. And hopefully it'll be both educational and a little bit of therapy for those of you who've had to deal with this. And maybe even before you get to that point, this will have some tips that'll help you out.
If I wanted to just kind of get a high-level view of the whole query, particularly if I had many databases, I would have to sum all of that information up, aggregate it every time I wanted like that high-level view. If I do that at creation time, I can store one row per snapshot and then store the detailed information separately if I want to dig in.
Welcome to this talk about optimizing auto vacuum. I've been working with Postgres for about a decade now, in different roles, doing different things with it. As an extension developer for the Citus extension, I worked on working with a lot of customers who've been using Postgres and Citus and are having performance and scalability issues, talking to them, helping them get the best out of Postgres.
Okay, I don't even know where to begin.
We can begin at the end. So Samai's talk, I think, is definitely worth watching. I haven't watched it yet. I haven't had the chance between all the live sessions, but
I've watched it.
How is it? I mean, it must be great.
It is. It is. And part of it is he just knows the topic so well, and he delivers it kind of calmly and clearly. It's really well structured. You know, he's been working on Postgres ever since he got out of college, and he has just built up all this expertise over the years. So and he's also worked both on the engineering side, but also directly with customers. So he kind of feels their pain as well. And so he shares all the tips and all the lessons that he's learned.
Yeah. I mean, it's definitely a talk for more when you're already in production, not when you're getting started with Postgres. But definitely, it's if you're running Postgres in production today, it's probably a good idea to watch Samai talk about how to optimize auto vacuum, because it's a very important topic for running Postgres.
Okay, we've got one more video and we only have a couple minutes. I have really appreciated you being part of this whole event. Thank you. And we are going to run the video, but first, in case we get cut off, I just want to say thank you to all the speakers, all the organizers, and everybody in the community who supported the idea, right? And who helped retweet and amplify and make sure people discovered it. So hopefully these learnings will help a lot of people, and people who are just entering the field right now. Maybe I call them newbies sometimes. Maybe I'm a newbie myself sometimes, but the more assets we have that help people learn, I just think the more we can grow and scale. So Marco?
And of course, thank you, Claire, for creating the idea of CitusCon and co-chairing it and organizing it. I know you've been awake for a very long time.
I have been.
So thank you so much.
All right. Yeah, we're going to run one more video. This has been a pleasure. I've had so much fun. My co-chair, Teresa Giacomini, is probably watching me right now. So, hey, Teresa, thank you as well. Let's roll this last video, and then it's a wrap. Okay?
And behind me, you see a fish. Bash fish is a symbol of our team. The Postgres team within Microsoft is called Orcus. So that is that fish sitting behind me. And in this session, we will go over top 10 reasons why you should choose flexible server over our existing offering, which we call single server.
Welcome to Handle Azure Postgres Auditing with Ease. I am Josephine Bush. I have a lot of DBA experience. I started SQL Server, and in the last few years, I've switched over. Well, I actually do both SQL Server and Postgres now in Azure.
So what does it actually mean in numbers? Interestingly, we have, with PostgreSQL, on that PostgreSQL database, basically, we analyzed 2.7 trillion of impressions from advertisements on the internet. Each month, we add 70 million of rows of data to our PostgreSQL database.
You need to pay attention to some very important points. The data types, type of index, most important operation in most main operation. This information gives you the basis for the correct choice for the following information.
Hi everyone,
My name is Claire Giordano, and I will be walking you through the journey I had while creating monitoring tools for Citus on Azure. In this talk, I will briefly explain what are the most important metrics are to babysit your Postgres database and why we should keep an eye on them.